Можно, Вадим, может, да? Сейчас обучу. Такой свет, можно и так было. Все, можно, да? Dear colleagues, ladies and gentlemen, we begin our session of the second day. And this is entitled Industry 4.0. We have several presentations, and the first one is by Gleb Turishin, professor and rector of St. Petersburg State Marine Technical University. I call upon Gleb Turishin.
Thank you, Kirill. Good morning, ladies and gentlemen. As it happens, now we live in the time of new industrial revolution, so named transition to the industry 4.0. And among all technologies of industry 4.0, only one technology is real industrial technology. It is additive technology. Additive, no, это аддитивное. And my presentation will be devoted to present stage of development of this technology and prospectus of implementation of additive technology to shipbuilding industry. So, really, there are a lot of different technologies which joined by the name of additive. But only one of them really allowed to produce large metal parts. It is technology of direct laser deposition. Прямого лазерного выращивания. Technology works with different kinds of metals and alloys, as it's shown here. It allows to have level of productivity on the level of several kilograms per hour and allow to get parts with the maximum sizes more than 2 meters. It's a reason why it's possible to use it in shipbuilding. And now it's used not only in shipbuilding, but also in the production of aircraft engines, missile engines, body parts for airplanes and rockets, and also ship propellers, parts of water jet engines for propulsion systems, and also in the energetic industry. Now let's look more detailedly onto different kind of materials which can be used for additive manufacturing. You can see here only a small part of the list of materials in which we have a successful experience of usage in production of real parts for industry. And what I would like especially stress, it is a level of mechanical properties which can be reached with this technology and this list of materials. And you can see that really additive technology provides a level of properties higher than traditional technology. A little bit to the basic fundamentals of technology, how it happens. The technological instrument join in one part two things. Optical objective, which focus laser beam, and nozzle, which provide gas powder jet. This laser beam and this gas powder jet join in one point. And in this point, we have a liquid or semi-liquid pool. One. And onto this pool, we feed metal powder. And after that, when we begin move our instrument along the trajectory, we can provide initially one melted layer, then we can put second layer onto first, then next, and with this sequence, we can create complicated metal shape with the sizes I told earlier. And you can see here some photos and sketches of such of cross section of the metal wall, which can be made, which was made with this technology. And by joining of these walls, we can get massive parts. You can see here cross sections of this massive part. And you can see that it is really solid. Which can provide the mechanical properties I also told. What else is very important for this technology? Because of technology connected with the heating and cooling of material along the process, we meet here strong influence of thermal stress and distortion. And you see here that when we simply want to produce cylindrical shape, we get shape which is not cylindrical, simply due to decreases of diameter of cylinder, simply due to cooling of material in the process of additive manufacturing. So we have to preliminarily calculate the influence of thermal distortion and compensate it when we prepare the trajectory of motion of our instrument. And you can see here that after this improvement, we can get accuracy of the part better than 0.2 millimeters. And with increases of sizes of parts, the influence of this effect becomes higher and higher. And you can see here part of control program for technological installation with improved trajectory. And you can see what happens without compensation of thermal stress. It's the upper layer of photos, and with compensation, it is a down layer of photos. Next part of technology is a quality control of the part which was produced with direct laser deposition. The best way of quality control is X-ray tomography. Рентгеновская томография. But because of size of the parts, much more than capability of X-ray tomographs, we have developed special robotic system which really work like a tomograph, but in the free space without chamber, and as a result we can test parts with the sizes, as I told, up to 2 meters. And let's look into examples of such parts. On this slide, you can see some parts which was produced for turbofan engines. Турбовентиляторных. Турбовентиляторных. Turbofan. You can see here parts of middle support of such engine. On the photo under this, you can see so named Blisk. Blisk, it is a circle with the blades, which was made like a unit. It was made from titanium alloy. You can see empty body is. I try to. No. It doesn't work. Oops. Okay. No, it doesn't work, so I will try to explain by voice. The empty body disk, which should be added by the blades, and I should say that this technology is the only one way to produce parts which are empty inside. And also you can see here parts of missile engines and rear body for turbofan engines and number of high pressure fans. This technology can be joined in one technological installation with mechanical treatment. And you can see here stages of production of bearing body on this installation, which is begin from solid simulation, solid state simulation, твердотельного моделирования. Then additive manufacturing of the part, then mechanical treatment of this part, then measurements of the size and shape, and the final drilling of the part. As a result, you can see final view of this bearing body. And what I would like to stress here, it is a total time of production from the very beginning up to finalizing of production. We have only 20 hours. Now let's look onto the size of largest part we have produced. It is external ring for prospective turbofan engines PD14. PD14, it is a new engine which was made in Russia for new plane MS-21. It also produced from titanium alloy. The diameter of this ring is a little bit more than 2 meters. And you also can see here the total time of production is really 128 hours, which is really 10 times smaller than traditional technology can suggest us. Now let's look onto shipbuilding applications. First of all, you can see onto empty body blade for ship propeller. It is on the middle right corner. Вверху справа. Да, в середине справа. It have 70 centimeters height. And time of production less than 3 hours. But also with this technology, it's possible to produce ship propeller from beginning to end. You can see here on the left corner the ship propeller. It have empty body blades with a special frame inside. These blades are empty body. But to save mechanical property of the propeller, inside this empty structure, there is a special metal frame which provide the level of mechanical properties. Another branch of application of this technology for shipbuilding is ship furniture, armatura. And you can see here some bodies of the parts for the ship furniture, which was produced, of course, with this technology. This technology also was used for production of water jet propulsion system, водометного двигателя по-русски. And you can see here propeller for water jet, external body, and also you can see the empty body structure of the blade for this propeller. Another branch of application, as I told, is production of parts for missiles. And you can see here the same level of sizes and the same level of productivity. And also, а можно сдвинуть фотки?
Убрать, да?
In the case, if it's possible to look, oh, wonderful. It is. If you will see on the cross section on the right corner, it is really a section of large cylinder, which is stand near. And you see that this cylinder have a complicated structure of cooling channel inside. The only way to get it is the usage of additive technology. Now let's look onto the equipment which allow to get such results. This equipment was developed and now produced in our university. In spite of we are university, we're a serial producer of technological equipment for additive manufacturing. And you see here our middle-size technological installation, which allow to produce parts with the sizes up to 130 centimeters, with all scale of materials I told before. Installation based on the fiber laser with power 3 kilowatts, which we use for the melting of a powder. Порошка. And you see here two vessels on the installation. There are vessels for the powder. So this installation can work in one time with two different materials. And we can produce parts which consist of different materials in different points. Here you see the large technological installation. The maximum size here is 220 centimeters, and productivity a little bit higher. And here you see hybrid installation which join in one machine additive manufacturing and mechanical treatment. And you see how this process looks in reality. And as I told, we can join different materials in one part. And you can see here samples for missile nozzle ракетное сопло, which consists of bronze inside and steel outside. So, and finally, talking about future development of this technology, the future steps are colored by red. And you see, we're working under the widening of the list of materials, under the increases of productivity of process, increases of the sizes of part we can produce, increases of accuracy and providing of the quality of final part which produced with technology of direct laser deposition. Thank you a lot for your attention. I'm ready for question if anybody have. Ну, веди, Кирилл, там спрашивай, если вопрос.
Okay, are there any questions? You can send them in written form. So thank you for your attention. And I think we can let Professor Turichin go.
Я еще посижу с
Not
вами.
yet.
No,
we'll keep him here. So let me now call upon Rudolf Korsmik. We'll make a presentation entitled Direct Metal Deposition of Topologically Optimized Vessel Propeller. Рудольф, есть у нас? Он должен знать. Где он? Рудольф. Не проспал, я надеюсь.
Так, ну что, звоним?
Да, позвоним. Я подключиться. Я пока другому расскажу. So as you see from the program, the next after Rudolf, there will be a presentation, Precision Power Limited, that's the name of the company. And the person who would be presenting is Aaron Gabat. And this would be on use of modern tech in small-scale industry. Mr. Vinit Brabordekar, who is here, as I understand. And the next presentation, also of great interest from viewpoint of Industry 4.0, would be autonomous shipping. And it goes about Russia national project to be delivered by Alexander Pinsky, who is Director General of Marinette Industrial Center.
Не берет телефон.
Hello. Yes.
Так, это интересно. А там кто-то с ним рядом.
Оленька, слушай, а у тебя Рудик не под боком нигде? Не делает. Вот он не вышел, я что и звоню, я на телефон не отвечаю.
Может, пока она им позвонит,
Позвони.
мы будем двигаться.
А где он говорит? Нет, вот мы сидим на индийской встрече. Он не подключен.
Он, знаешь, наверное, вторую ссылку надо, второй день.
Второй день. Ссылка, второй
Другая
день.
ссылка там.
Другая ссылка.
Я объяснял.
Рудольф, мы тебя не видим тут.
Рудик, по второй ссылке надо выходить.
Скажи.
Рудольф, выходить надо по второй ссылке, которая есть прямо на программе. Если она у тебя где-то под рукой, это другая ссылка. Day 2 – это другая ссылка. Не видишь ее? Нет? Что, может быть, тебе прислать? Ты не заходил, а у тебя сейчас как раз доклад. Да, уже доклад. Долго тебе заходить?
Ну, давай, если Пинский готов, то пусть Пинский, потом Рудовин.
Тогда, наверное, индийский доклад запустим, да?
Ну, запускай, да.
Давай, хорошо, готовься, мы тебя вызовем тогда. Dear Indian colleagues, for the moment, I think our second presenter is being prepared, so we can use the time now and pass over to the next presentation, use of modern tech in small-scale industry. If Mr. Vinit Prabhudekar is here, and if some of your colleagues could describe his CV, could tell a few words about his biography, we would be grateful.
Professor Kirill, if you permit me, I would like to say a few words about Vinit. Professor Kirill, is it okay
Commodore
if I say a few words about Mr.
Deshmukh.
Vinit? Yes. Mr. Vinit Bhambudekar is the director of the technology in the Precision Power Limited, located in Aurangabad. The company is very technically oriented and is very adaptive and nimble in the technology adaptation and giving the very useful product to the customer. The company provides various products to the Indian Armed Forces, and they are very well accredited at naval headquarters, giving the products which are meeting the high technology requirements arising for the Indian Navy, especially in the power supplies and other sectors. Mr. Vinit has been responsible for instituting the measures and putting in place the processes which have increased the manufacturing efficiencies as well as resulting in a financial savings to the company. It's very credible on part of Mr. Vinit Bhambudekar to put those measures in place which are as such applicable to the whole SME sector. So on behalf of the organizers, may I request Mr. Vinit Bhambudekar to take the stage and make the presentation. Thank you so much. All the best.
Thank you, Deshmukh sir, for the introduction and the kind words.
Thank you very much.
Good morning, everyone. My name is Vinit Bhambudekar. Yeah. I hope my screen is visible.
Yes, go ahead.
All right. So I'll be talking about modern technologies that are being used by the MSME industry today. Before we begin, although Deshmukh sir has given a brief introduction about our company, I would just like to elaborate a little bit on that. We are an ISO registered company. We are an electronics manufacturer. We started off with power electronics as our main domain, but today we have expanded to control systems, embedded systems, sensors, and software. We have multiple locations across India in all the major cities, and we have participated in prestigious defense projects, primarily for the Indian Navy. And recently we have ventured into the Indian Army and the Indian Air Force. So to begin with, every product that is to be, every project that is to be converted into a product, we believe in our company there are two stages to it. The first stage is designing it, understanding and designing the project, and then converting it into a tangible product through manufacturing practices. So my first section of the presentation will focus on the designing aspect of the project. With the new, with ever evolving processors and faster internet speeds, most of the major companies have ventured into something that we call the cloud. So what exactly is cloud? Let's imagine a situation where you have you need to incorporate a lot of IT practices. You need to incorporate a lot of algorithms or some software that is going to cater to your designing aspect. Now, with ever increasing teams, it becomes very difficult to collaborate, or it becomes very difficult to work from one location. That is where cloud comes in. These are remote locations all across the world, which host, which aid in data storage, which aid in computation. And in the recent years, there's been a big boom. Now, with this processing power that is available at these what we call server farms, they can be provided to SMEs at very reasonable costing. This is extremely helpful because SMEs do not have to worry about putting their capital into developing an IT infrastructure, which over the years will keep on getting more and more expensive. There's absolutely zero maintenance, and you do not even need an IT team. Most of the solutions are one-click solutions, and you can start almost instantly. A lot of companies today, specifically MSMEs, have shifted their entire IT infrastructure to the cloud and are utilizing services from Amazon and Microsoft and all the major large MNCs to utilize their resources for their design needs. So using this whole concept of the cloud, the first thing that we can talk about is the version control. Every project that from scratch to finish needs some sort of tracking, needs some sort of versioning. I'm not talking about project management per se, but say a particular design is in process and there are multiple engineers working on it. You need some way to track what changes have been made or what version is being currently worked on. This is extremely important because when during the design phase, there are a lot of changes that can go about in any particular project. And if there is no versioning system in place, you will tend to make a number of backups within the same local computer. There may not be a proper tracking system as to what changes have been made. For example, if you're working on a 3D model of a product, there may be certain parts that were there in version 1, but in version 2, it was realized it's not required. And then in version 3, you want to go back to version 1 and try to see what changes have been made. Without a version control system in place, this is impossible, or it's a very tedious job. So we utilize two types of version control at our facilities. From the documentation and the designing point of view, by designing, I mean 3D modeling and FEM analysis and all, we utilize a software called SolidWorks PDM, SolidWorks Product Data Management Software. This maintains all the changes, all from the documentation point of view, all the way till 3D modeling. Every nut, screw, bolt, or sub-assembly, main assembly, every change, the smallest of the change is logged and is available to the engineer for further processing. For our software, for the source codes that we write, we extensively use the Git Versioning System, which today is an industry standard across major software companies. And this not only provides us version control, but also it gives a way to branch the source code into multiple segments, which can then be merged together So if there are multiple people working on the same project, one team can work on a particular part of the code, say, for example, the user interface, and the other team can work on, say, the database part of the project. And since it is all happening it is all happening simultaneously, at the end of the day, when the code is complete, it can be merged through this technology. This saves considerable development time. There is very less overhead, and individual teams can concentrate on what they are supposed to do rather than worry about what the other team, whether the other team's code is going to integrate with theirs. Now, how does cloud come into place for all of this? Naturally, because this is there are multiple teams working on it. There are multiple engineers designing the product. You need to have this hosted somewhere. So this is where the cloud solution comes in. So all of this can be hosted on one of the major cloud providers. Of course, because it's a data that is sensitive to our company, everything is highly encrypted. The encryption is happens at the check-in level. By check-in, I mean when you are done with your changes and you want to put it on cloud. That is where the encryption happens. And at the same time, when it enters the cloud and it is being put onto the dedicated storage, there is another level of encryption that goes on it. The next thing is after all the designing and the development process is about to be completed or it's ongoing, there has to be a way to back up your data. Now, the way we handle it at our premises is every facility of ours, since most of the computer clients are connected to the internal network, there is always a central storage. So the data for the day that has been, whatever has been developed, has to be checked in to the local storage, the central local storage, where it is further encrypted and then sent to the cloud. Now, in this case, why the central storage is important? There are two aspects to it. Although your data is going to go to the cloud, you need to have fast access over, say, a high-speed line of 1 Gbps, because there's going to be a lot of handshaking between the local storage and the computer clients. So this not only provides a redundancy, but it also provides every engineer a large storage network, which is completely accessible within the premises. Data redundancy is extremely important because today, if in today's scenario, if there is a power loss or if there is some data corruption because of a hard drive failure or something, the data is always going to be available on cloud. The solution, the backup solution that are being utilized are one-click backup solutions with one-click backup and restore. If there is any situation where data recovery is required, it's simply a matter of downloading the backup from the cloud over a secure protocol, and then just by one click we can put it across the central storage, which automatically propagates that restored backup across all the clients. This change has been recently imparted in our company, as recent as around 2 years ago, and this has drastically improved our project performance. Our engineers today do not worry about data loss. They do not have to think about any problems that may arise from theft or accidental deletion, and their focus is more on developing the product rather than thinking about what is going to happen if my device fails. Now, coming to collaboration, we spoke about in the previous slide about source code collaboration and product lifecycle collaboration. But what about day-to-day activities? How do we collaborate with everyone, and so that they're working on the same document. They're making sure that certain data that has to be shared or can be viewed. How do we achieve that? Now, given that the cloud technology boom in the last recent years, there are a lot of services, most notably Microsoft 365, which was earlier known as Office 365. Documentation, simultaneous working on the same document, email services, and virtual conferencing using Microsoft Teams. It has become very, very easy and very extremely cost saving. Buying a license of Microsoft Office before cloud was in place used to be extremely expensive for MSMEs. A normal license that could be used, that is to be used inside enterprises like businesses, used to cost near about $300, and it used to be valid only for a year. With the subscription and the cloud technology in place, today we can have the same Office license, the same capabilities, up-to-date software at a very low cost on a monthly subscription basis. This significantly reduces the cost incurred by any MSME, and but they are provided with the same facilities that every other large enterprise has. For supply chain management, we use a dedicated ERP solution from a company called Focus. Everything is automated from creation of the project and work order all the way up till sales invoicing and billing. There is direct access to a lot of facilities on the software, such as accounting, purchases, project management. And this is, since it's all hosted on the cloud, it is accessible to every company personnel worldwide. Now, with so much infrastructure, cloud infrastructure in place, there needs to be some sort of a secure platform where everything will work. You cannot just have a laptop with Windows running on it and you access these cloud technologies. You need to have a robust security solution in place. So what do we use that is not only cost effective, but also provides the required performance and security? We are using, for the local computer security, we use the Windows native BitLocker system. A brief introduction on that is BitLocker is a way where there is encryption happening locally on your drive. So if your computer or if your equipment is stolen, or if someone is trying to hack into your system and try to extract certain data, it is completely secured via BitLocker, because the user is, any person trying to invade your system is not able to access it without a particular key code. The key code can be either a text file, it can be something on a USB flash drive, or it can be linked to your organization's profile online. Accessing cloud technologies is through SSH protocols, or what we know in the IT industry as secure shells. It's not just password authenticated. There is a key file that every engineer is provided, so that even if their password is leaked, unless and until someone has access to the key, they will not be able to log into any of the facilities, any of the cloud technology solutions that we use. And to secure all of this, on top of everything, there is a centralized security solution, enterprise-grade security solution for antivirus and malware and ransomware attacks and all. We have gone ahead with Bitdefender, which provides us a central console, which is available on the cloud. It is directly connected to our computers via a relay service that is again provided by Bitdefender itself. IT infrastructure for the hardware is, we believe it's the most important thing. for an R&D company. We being primarily an R&D company, the development time at at any of our facilities has to be as short as possible, especially when it comes to 3D modeling and design and compilation of code. We do not want any sort of slowdowns. Issues of hanging or freezing are very rampant in an environment with multiple computers, with multiple network access. For that, we have made sure that our engineers are provided a minimum of Intel i5 processors with 8 GB of RAM. This is needed because when you're working on high bandwidth applications, having a slower processor or not enough RAM can drastically reduce the development time. Can drastically reduce the capabilities of the software that is being used. For example, if we are talking about, let's take code compilation example. Software that is developed can be as long as 10,000 lines of code. Compiling 10,000 lines of code there can be a difference of from 10 minutes all the way to 25 minutes, depending on the processing power. So this itself, over the year, over a daily usage, can add up to hours and weeks of compile time, which can be drastically cut down by using higher end equipment. Another major change that we have done is we have shifted from hard drives to solid state drives. This, in my opinion, is one of the biggest changes that I believe any MSME can go through, because it changes how you look at a computer system drastically. When we talk about OS loading times, say from switching off the computer to switching it on, loading into the OS, and then starting the program that you want to run, we have seen incidences where this goes to beyond 10 minutes and whatnot because of the slow nature of the hard drives. Typically, a mechanical hard drive will have a disk running inside with a header that will point onto the disk and then extract the data, which is a very, very slow process over long sessions. In a solid state disk, there are no moving parts. Everything is through a flash memory and everything is directly accessible. This increases your load times to mere seconds, and within 2 to 3 minutes, you are into the system, you're logged into the system, and you're working on the software for the product development. All of this needs a robust internet connection, and since we are dependent on cloud, we are dependent on hourly backups of our system, we have a dedicated lease line which provides us unlimited upload and unlimited download of data. This technology used to be very, very expensive, say around 8 to 10 years ago. But recently, since 2015 to 2016, the prices of lease lines in India have dropped dramatically. And I think that's the case worldwide as well. And a lot of SMEs are embracing lease lines for their security and for their unlimited data usage. In terms of software, we are a company that believes in using open source software wherever it's possible, because it provides our developers freedom. We can work directly on the source code of the software if it is permitted by the company. But in cases where we cannot use open source software because of certain limitations, or because the development time to make something like that in the open source software will be much higher, there are licensed softwares that we use. When we deploy applications for the Indian Armed Forces, primarily for the Navy, Indian Navy, we have extensively used Linux deployments all across our equipment. We, although it has been a requirement from the customer as well, but in cases where the customer is requesting for Windows, we try to explain to the customer why Linux is important and how much more secure it is compared to Windows. And that is one of the reasons why we also use Linux for our cloud hosting, for our cloud platform solutions. Since we are an electronics company, we need a lot of PCB to be designed in-house. For that, we use a software called KiCad, which is freely available. It's open source for small deployments for test boards and everything. But for major multi-layer PCB design and all, we have a licensed software from OrCAD. It is one of the leading providers for PCB solutions. In the past slides, I've mentioned we use SolidWorks for our product data management, but we also use SolidWorks for our 3D modeling, since it is one of the leading companies in the world. It's the leading software in the world that provides accurate 3D depiction, which can be converted into 2D, which is then transferred over to AutoCAD for development drawings, which can then be sent to the manufacturing department. With the recent advancement in technology, a lot of our documentation has shifted to IETM based documentation. IETM is an interactive electronic technical manual. These are now being demanded by the armed forces in India as well, specifically the Navy. The biggest advantage of an IETM document compared to a standard document is that it is highly interactive. The interactions can go from not just viewing 3D models, but to advanced tagging, advanced searching. Any user that is able to, that has access to the document can create his or her own profile in the IETM document and can have a customized experience. We have IETM level documentation for our internal use, as well as we have provided a few IETM level documentations to the Indian Navy as well. They are mostly web-based or PDF applications. So the cost overhead is not a lot, since web development can be, you simply need a device, a simple computer to do web development. Current technologies that we use for IETM level documentation include JavaScript and Python. And for PDF, we use Adobe Acrobat. Now, after all of this has been designed, we need to convert it into a tangible product. So for that, we use various manufacturing technologies. To begin with, when it comes to the PCB, after the PCB has been designed and fabricated, it goes through a wave soldering process. It goes through a component, it goes through an SMT line, where all the components are automatically placed on the PCB and are also verified there for continuity checks and to see if the power testing, the power functionality is correct. Post that, it is put into in the same facility. It is put inside specialized fixtures, which, if it is an embedded system, will check the microcontroller for signals and to make sure that the connections from the microcontroller to the junctions are accurate and correct. For manufacturing of the product through sheet metal and all, we use advanced machines for CNC punching and bending, and where in places where high accuracy is required, laser cutting is utilized. The fabrication of the unit is done via fixtures, and manual fabrication is kept to a minimum to avoid human error. Once the PCBs are manufactured, they have to go through a conformal coating. The conformal coating is the last stage that is done after the PCB has been tested, before it is placed inside the fabricated enclosure. The conformal coating is extremely important as it protects the components on the PCB from moisture, dust, and extreme temperatures. Finally, once the prototype has been manufactured, it undergoes environmental stress screening, or what we call ESS, in specialized labs. This test is, it tests the unit, it tests the prototype for temperature usage and for vibration. Post this, it is followed, every prototype is followed with 72 hours of burn-in, where it is subjected to the highest functional test or the highest load, if it's a power electronics device, possible for complete 72 hours. This is extremely important because our customer, being the armed forces, the equipment can be used in a lot of harsh environment. And so this certifies, this makes sure that the product is ready and ensures its mortality and reliability. Post
हम लोग एडिक्टेड हो साला पैसा आने वाला आनंद भाई कब आएगा परसों ठीक है आज थोड़ा नेलो मजे में तुम्हें चेंज बताएगा मुझे भाई हां मुझे चेंज बताता है अरे 7,000 रुपया जा रहा है 1 लाख रुपए तो हम लोग जिस कॉलेज में पढ़ रहा था ना वहां पे तुम अगर यदि अपना थ्रू से किसी का एडमिशन कराएगा ना तो पढ़ने मिलता है
प्रोफेसर व्हाट इज दिस डिस्टर्बेंस
मिला कि नहीं पैसा तो मिला पर काफी लेट
प्रोफेसर दिस डिस्टर्बेंस इज फ्रॉम वेयर
Yeah, okay, it's muted now.
Dear colleagues, we have to pass over to other presentations, so
we are done.
Maybe 5 minutes more, if you don't mind. Oh, this is for thank you even too much.
Yeah.
Thank you very much.
Thank you for
thank
your.
you very much. It's been very interesting, and cloud technologies. Да, облачные технологии сейчас очень популярны. Вообще индустрия 4.0 сегодня. Вот мы проводили недавно большую конференцию ПАМЕС, где приложения этой индустрии, включая облачные технологии, рассматривались к судостроению и к судоходству. Поэтому я считаю, что это очень интересный доклад. Спасибо компании Precision Power Products. И давайте будем в контакте. Я уверен, что мы найдем основу для взаимодействия. Сейчас мы переходим, господа, если вы не возражаете, к следующему докладу, который уже готов к представлению. Он называется Direct Metal Deposition of Topologically Optimized Vessel Propeller. Рудольф, можно включаться, извини, что тут долго затянули. Электричество, да? Ну, да, ну что-то починится там или что? Что ты можешь делать? Можешь что-то делать? Второй раз зовут. Ну, давай так, мы сейчас поставим другой доклад. Сейчас у нас Александр Пинский на связи. А ты попробуй еще, ладно, что-нибудь, потому что у тебя очень интересно. Ну, давай посмотрим. Dear colleagues, I think our next presenter is now experiencing blackout. He doesn't have electricity in his house. So if you don't mind, I'll pass over to a very interesting presentation by Alexander Pinsky, who is Director General of Marinette Industrial Center. And it is entitled Autonomous Shipping, Russia National Project. Александр, пожалуйста.
Thank you, Professor Rogdetsky.
Не слышно.
Can you hear me?
Сейчас слышим, Александр.
Excellent, thank you very much. So again, thank you, Professor Rogdetsky.
Сейчас не слышим.
Он не в тот канал говорит.
В канал нужно, да? Нужно. Вы будете по-английски, Александр, или по-русски? По-русски, да?
In English.
Не слышно.
Коллеги, я на английском буду. На английском. Я в английском канале.
Мы не услышим?
Конечно, у нас здесь настроен на русский канал.
Если можно, по-русски, потому что мы здесь не будем слышать ничего, к сожалению. Можно так, по-русски, Саша?
Подожди,
ну, хочешь по-английски. Ну, сейчас ректор же выступал по-английски. Ничего.
Ну,
давайте по-английски, по-английски. Okay. Let's speak English, Alexander.
Okay. Thank you very much. So, good morning, dear Chairman, distinguished participants of the conference. I'll start my presentation.
Ну, все отлично. Он говорит по-английски, нам переводят по-русски, для русских.
Can you see it?
Ну, дело в том, что специалисты лучше знают свои темы по-английски.
Well, colleagues, may I continue? So, first of all, I'm glad for the opportunity to share some information on recent autonomous navigation developments in Russia, which I believe would be very interesting topic for our cooperation and could be a very beneficial opportunity for our Indian partners. So, first of all, a few words about autonomous navigation. Implementation of maritime autonomous ships, that is automatically and remotely controlled vessels, is one of the most demanded and one of the most hottest topics in the maritime industry today. On the one hand, it will significantly increase safety of navigation, eliminating the human factor, which is a major reason for maritime incidents, especially in the situation of increasing deficit of the qualified seafarer. On the other hand, it will reduce operation cost of ship owners due to decrease of the cost on the crew on board, bringing better management and better control of maritime vessels. Probably it will be the first time for many, many years when ship owners will not pay for extra safety with extra costs. That's why this technology is extremely expected and demanded today in the maritime industry. So that's why in many countries, currently there are different trials, different developments and projects in this area. And in Russia this year, we are making very important step. We are reaching important milestone, not only for Russia, but for the global maritime fleet. We are completing the world's largest trial project, and we are starting a national experiment which allows for any shipping company to equip with autonomous navigation system any ship under the Russian flag and legally operate them in commercial operation. So the first time we bring these new technologies to the hands of the customers. You know, my strong opinion that new technologies are developed and maturing not in research centers, not in technology companies, but only when they come to consumers, to the customer hands. That's why in 2019, 3 Russian major shipping companies, Rosneft, and Polo Group, together with different technology companies, with maritime universities, joined under umbrella of Marinet to make possible from 2021 wide practical operation of autonomous navigation technology. We, from the very beginning, we defined 3 major challenges. As to regards, and I would say not only challenges, but also the aims, the targets of this project. The first of all, our colleagues from shipping companies would like to have these technologies predictable and transparent. So it should be not something like black box artificial intelligence. Everybody would like to see autonomous vessels as a predictable and transparent for ship owners and for all participants of the maritime process. Next, this technology should should be accommodated within the existing international regulation, because as you understand, any changes in international conventions will take many years, and we are actively participating in the work of the International Maritime Organization in the area of the development of maritime autonomous ships regulation, and we understand that the changing in international regulation would require at least 5 years. This is the very optimistic view on this topic. And the third challenge, the third aim, that this technology should be affordable. One of the disadvantages of different trial projects in this area that these new technologies are extremely expensive and fragmented, and as a result, they cannot be utilized by shipping companies right now. So during this project, we had to develop technologies which are affordable and available for the practical use of shipping companies right now. As a common response for all these three challenges, we have developed our own methodology, which is named as a complete functional equivalence principle. The idea of this principle is pretty simple. Independently to the way of control, in automatic, in remote control, as well as in traditional manual, our vessel has to fulfill all the requirements which are currently prescribed for the crew on board. On the one hand, it allows to work within the existing regulation, since we are fulfilling all the safety and navigation requirements. On the other hand, it allows us to make behavior of autonomous vessel predictable, absolutely the same as a traditional vessel. So if you meet autonomous vessel following this principle, you will not see any differences. Maybe the only difference that this vessel will follow the regulation requirements more precisely rather than human, rather than manned driving vessel. To make this, we took as a ground STCW code, which is already pretty functional oriented. So we took every function which is currently prescribed for the crew on board, and we analyzed all the requirements to the human officer right now, and implemented them as a functional requirements for the automatic, for the computer systems, and for the remote control means. Again, depending on different vessels, we can have different combinations of the functions. Here, for example, you may see one of the examples of the functional map when most of the functions in watchkeeping, in technical control are implemented in automatic mode. Some of them mostly related to communication with other humans during the process of navigation belongs to remote operator, and some of the functions, for example, like crew management or search and rescue operation or care for passengers, to be done by crew on board. Based on this, we have developed the national regulation within the existing international regulation. I will not spend too much time on this topic right now, because I believe we don't have too many people from shipping companies and ministries of transport. In general, I will say that we have 3 levels of regulation. The federal law explaining liabilities and legal relations which are interpreting the international regulation in specific issues highlighted by the International Maritime Organization during regulatory scoping exercise. The second level is under law documents like government regulations on the national experiment, which, as I said, allows any company to use autonomous vessels under the Russian flag within this national experiment. And we have the third level, which is technical regulation, including rules for classification of autonomous vessels and rules for cybersecurity issued last year by Russian Maritime Register of Shipping. It is an international classification society based in Russia. And also, again, firstly in the world, the same as the first national regulation of autonomous navigation, we have developed firstly in the world recommendation on application of call regs by Russian Federal Maritime and River Agency. So this is the first time when call regs provisions are explained in mathematical, algorithmical way by Russian Maritime Administration, which allows to use this recommendation as a ground for the development of computer system and for certification of this computer system by classification societies. All this information was provided to the International Maritime Organization, and as I said, we are actually participating in the development of the international regulation following these approaches. And I see that more and more countries are joining us in this approach. Also, we have developed the set of technical solutions which are applicable for any kind of the vessel. First of all, we are talking about the existing retrofit vessels, so we don't need any new type of vessels, any fancy ships. Here you may see the system architecture. Again, since we need to make these technologies affordable, we utilized as much as possible the existing technologies. Here you may see that we have mandatory systems like radar, IS, compass, gyro, and other navigational devices. We have a mandatory technical system, signaling system, messaging systems, which are already installed in every vessel compliant to SOLAS. Also, we utilize the conventional traditional systems, for example, technical control systems. You know that there are ships with unattended machine rooms, and the only thing which we did, we took remote control, which is typically currently on the ships are placed in control centers on the bridge. So we took these control stations outside the ship. The same we have already now different motion control systems like dynamic positioning, like trajectory following systems, and again the only difference that we send commands to the system not only by human, it is done right now, but also by computer system and remote control station. So actually the only three systems which we developed are pretty new: autonomous navigation system, optical surveillance system, and remote control station. Autonomous navigation system, I hope you may see a video on this slide. It is one of the examples of trial of the systems in real commercial operation. So during the trial project, we installed our systems on board on three absolutely different commercial vessels, and during commercial operation, we use the systems already about 1 year. So autonomous navigation system is actually equivalent of officer on board, which integrates all the data from navigational devices, from technical devices, the same as it is done currently by officer in his mind, identify dangers, and calculates maneuvers to avoid these dangers in accordance with call regs, based on this recommendation by Russian Maritime Administration on application of call regs in autonomous vessels. Also, it provides interfaces for human, both on board or in remote control station, which is more or less similar to this. As you might see from this video, it is pretty the same like this, but with additional overlays, with additional interfaces reflecting autonomous navigation system work. Next, we have optical surveillance system, which is actually equivalent of human eyes. Again, in different other projects in other countries, sometimes people are avoiding optical systems, saying that technical vision like radar or IS is already enough for surveillance for awareness, situational awareness. But since we are following this complete functional equivalence principle, since we are following all the requirements by international conventions, and all these international conventions are currently requiring visual surveillance, we made this optical system which is automatically recognizing objects around the vessel, sending parameters of these objects in machine reading form to the autonomous navigation system, and also provide this picture to human interfaces, firstly to the remote control station. Again, all these videos are just examples of real operation on different vessels. So as you might see, the remote control station is more or less the equivalent of the bridge, but outside the vessel. So we have video interfaces allowing a remote operator to check the situation around 360 degrees, up to 12 miles. We have interfaces to all systems. For example, here you may see navigation system, autonomous navigation system, technical control system, direct link to the crew on board, and etc. Also, we have interfaces for radio communication, and as you may see, we have a joystick system which allow to remote operator to directly control the vessel in cases that is when it is required. In general, our approach is that 80–90% of the voyage, the vessel is controlled automatically. In standard situations, in high seas, automatic control by autonomous navigation system is working well without any problem. In some non-standard situations, in some cases, like for example, pilotage or work in port waters, etc., we need a human control, mostly by remote control operator. So here you may see how it works on board on a general cargo ship Polo Anfisa in Mediterranean and Black Sea. And here you may see that remote operator switching from different ways of remote control, and also I'll try to jump to the next. Yes, and here you may see it is turned into automatic mode when the vessel is controlled by autonomous navigation system. So, as I said, one of the important part of the trial project is trial operation in real commercial conditions. Polo Anfisa, Рабочая, and Mikhail Ulyanov, three absolutely different vessels which are continuing commercial operation without any breaks. And during this commercial operation, master on board just activating from time to time this autonomous mode. So starting from September last year, after preliminary tests on board using ashore using simulator, we started trial operation. The first stage was, as we say, passive mode trial operation when our autonomous navigation system and remote control station were not connected to actuators. They were just gathered data and provided calculation, but without access to actuators. In December, we've got approval in principle by Russian Maritime Register of Shipping for this set of technical systems. Again, this is the first time in the world when classification societies issued approval in principle for autonomous navigation systems. And starting from February this year, we use already automated and remote operation with access to actuators. Here again, you may see how it works in reality. So the system is recognizing, is identifying dangerous vessels, dangerous objects, calculating maneuvers, and executing these maneuvers automatically. And currently, we are at the last stage. From September this year, we are making demonstrational voyages in real operation, and also we expect for the last legal document to be approved by the Russian Parliament, and after that, we are starting national experiment on air navigation. We already have several shipping companies, and more than 20 vessels are intended to be equipped with autonomous navigation systems in Russia. Here you may see some examples of these vessels, which will be already not experimental, but officially autonomous vessel with official category of autonomy and with autonomous navigation system as a main equipment, not as experimental. For example, one of them will be a railway ferry working between Kaliningrad and St. Petersburg. It's about 1,000 miles road. So, as I said, currently we are starting firstly in the world wide practical operation of autonomous vessels, of autonomous navigation technologies, and we are ready to share this experience and these technologies with our partners in India. We are ready to share our technical systems, our experience, how to deal with classification societies, with regulation, how to integrate these technologies with the existing technical solutions, how to incorporate this to the existing retrofit vessels to upgrade this to autonomous level. And we believe that it could be pretty interesting, promising, and beneficial topic for our Indian partners. So if you have any interest to make at least such a trial in India, or to develop a more commercial cooperation in India in area of autonomous navigation, we are ready to support you. We are ready to provide any required assistance, both from technical and from procedure part. If you want to have some more details, you may go to enough.org with some more detailed information about this project, as well as you may contact me and my colleagues via these contacts. Here I'm completing my presentation. So thank you very much, colleagues, for your attention. And I believe it could be...
Александр, огромное спасибо. Огромное спасибо. Но Александр занимается прорывными технологиями, как вы видите. Наверное, это единственный в мире вот такой национальный проект, российский национальный проект автономной навигации. Насколько я знаю, Александр сейчас вот в целом ряде стран сделал вот такие вот доклады, огромный интерес к этим докладам. И самое главное, что есть эксперименты, есть там, не знаю, 3 или 5 судов, которые разнотипных причем, которые показывают возможности, дают возможность дальше двигаться по разработке. И самое главное, что интересно, мне кажется, что есть возможность альтернации режимов различных. То есть это может быть просто автоматизация управления судном, это может быть сочетание экипажа с автоматизацией, это может быть как бы дрон, то есть безэкипажное судно. И эта работа, к этой работе относится с большим интересом специалисты многих стран. Поэтому пожелаем Александру Савельевичу успехов дальнейших. Будем рады следующим докладам по новым достижениям. Спасибо большое. Спасибо. Так, коллеги, сейчас мы попробуем перейти к докладу, который мы пропустили. Это доклад Корсмик. Доклад Корсмика, который называется по-русски, я тогда прочитаю, «Прямое лазерное выращивание оптимизированного судового грибного винта». Кроме Рудольфа Корсмика, с авторами являются профессор Туричин, который выступал здесь, и профессор Родионов. Александр Александрович Родионов является заведующим кафедрой строительной механики. Вы слышите? Do you hear me?
Yes, I do.
Okay. Профессор Родионов является заведующим кафедрой строительной механики корабля нашего университета, специалист по оптимизации, автор целого ряда книг и монографий на эту тему. И вот в работе по грибному винту, насколько я знаю, об этом Туричин говорил, он применил метод оптимизации для некоторой рамки металлической, Рудольф меня поправит, которая внутри этой полой лопасти находится для обеспечения прочности. Пожалуйста, Рудольф, надеюсь, что мы не вылетим по электричеству.
Надеюсь.
Рудольф Корсмик.
Good day, dear colleagues. My name is Rudolf Korsmik. I am head of
Ничего страшного, пускай по-английски говорит.
Institute of Laser and Welding
Но ему
Technology.
удобнее так, потому что переводчики хорошие.
University. And I decided to enlarge my presentation from the one topic of vessel propeller to different approaches to design and manufacturing of large-sized marine machinery parts, which we produce by direct laser deposition. Scientific and industrial actuality of additive manufacturing. The replacing of existing technology for manufacturing parts by a new one is possible only when at least one of the three components of quality, productivity, and economy of the new technology becomes higher, while the rest ones do not decrease. Thus, we can say that the problem of introducing additive manufacturing into industry is becoming three-dimensional. If the importance of quality as one of technology components is clear to all of us, products must meet operational requirements then the answer is not so obvious with capacity and the economy. The capacity will affect not only to economic efficiency of the process, but also the quality of the product. And that's why large-sized items that we manufacture in most cases weight more than 50 kilos. And in some cases more than 100 kilos. If the capacity is about 500 grams per hour, then a product weighing 100 kilograms will be produced for 200 hours. Over time, the probability of an incident will only increase. As a result, the quality of the product may suffer. At the moment, we have achieved productivity of 1 to 2 kilograms per hour, depending on the alloy. Finally, the economic component. Experience shows that not all plants are ready to introduce a new technological process, which will cost them more than the existing one. Therefore, for the successful introduction of additive technologies into industrial production, it's important to determine the market niche that they can occupy. So, to realize the technology of direct laser deposition of large-sized parts, our institute designed and constructed multifunctional machine with bearing capacity up to 500 kilograms and processing zone up to 1.2 meters in diameter and 600 millimeters in height. The machine is made in a steel design for ensuring overall shielding of the part. This allows processing alloys based on iron, titanium, and copper, besides two alloys that local protection of molten pool is enough. The main components of this machine are fiber laser with maximum power of 3 kilowatts, laser focusing head with focal point up to 200 micrometers, cladding nozzle self-made production with focusing gas powder jet up to 3 millimeters. 2-axis servo positioner and the industrial robot with reliability of 30 micrometers. Now let's move on the approaches of designing the process of manufacturing parts of complex geometry. As you can see in the left picture, this part is quite non-trivial for layer-by-layer manufacturing, as it has a number of overhanging structures. Given the fact that any supports and additional substrates cannot be installed, the production of such part is truly a technological challenge. To build up this part, its 3D model was separated to several primitives, shown in the figure with numbers from.
Извините, запустите, пожалуйста, слайд-шоу, Рудольф.
Okay. Yeah. Is it better?
Если не получается, ничего страшного, можно так говорить.
Yes, I cannot unfortunately. Okay. Yeah, the position of each next primitives begin after ending of previous ones. And during the manufacturing of primitives 1 and 5, the positioner was in a horizontal position and in vertical position during the position of rest primitives. Another problem was to avoid the residual stress and distortions. How can see in the central section of the right picture, if we clad whole size of the primitives, which is colored red, there is presence of residual deformation. And when we move to the opposite one, the cylinder's generant is no longer straight. This way, formation of our primitives begins impossible. To mitigate residual distortion of build-up parts, we adopted well-known approach widely used in welding. This approach is alternatively welding on either side of the joint. Thus, build-up of components of 2, 2, 4, 4, and other goes alternatively layer by layer on either side. The next approach in manufacturing of parts with adjusted dimensional accuracy is compensation of distortion. To realize this method, initial geometry should be pre-distorted. To do this required the final shape of the part manufactured using the original model. The distortion compensation consists of inverting the deformations predicted by finite element simulation, followed by modifying the original mode. The obtained distorted shape of the build-up part is shown in the center picture. Here could be seen that shrinkage of bulky flange leads to the reduction of the radius by 4 millimeters near the top of the hemisphere. Radius of curvature in this area is also significantly changed. The flange has a significant deviation from the horizontal axis. In order to obtain part of the required shape and size, the initial cut model was modified by applying inverted deformation. And vessel propeller, yeah. One more application of computation methods to design of parts that could be manufactured by direct laser deposition is topological optimization. And there is a truly symbiosis of two advanced technologies. Because additive manufacturing method can help reveal the full potential of topological optimization applicability in real parts. Here you can see the experience of designing and further manufacturing of vessel propeller. For this project, a 3D model of real solid propeller with 900 millimeters in diameter was taken. The first optimization step was to identify areas that can be optimized. As you can see in the left picture, only the outer surface of the hub, blades, and the central cylinder to fit on the shaft were not subject to optimization. For optimization, the solid isotopic material with penalization methods was used, which assumes the presence of an isotopic material with fictitious density at each point of the body. Thus, if density equals 0, then the elastic properties are also zero, which indicates the absence of material. If density equal unit, the elastic properties at the point are the same with the original properties. To compute elastic properties, the areas to optimize are filled by finite elements with a dimension of 4 millimeters with the hub and 2 millimeters for the blade, how it's shown in the center figure. The result of internal propeller space optimization is in the right figure. You can see that the blade structure has reinforcements similar to insect wing or tree leaf. However, for the hub, the optimization result is not so aesthetically pleasing. Essentially, there's 4 monoliths located under the blades. In the end, the overall weight reduction of optimized propeller was 26% compared to the original one. This slide presents the stages of manufacturing of topological optimized propeller via direct laser deposition. And let's try to see a video. and building of so in most cases, the dendritic structure is formed in the crystallization of metallic materials. The crystallization velocity and the temperature gradient determine the microstructure of material in the process of primary crystallization. The first arms of the dendrites are predominantly directed parallel to the heat dissipation and along the preferred crystallographic orientations. As a result, the structure of even one bit has anisotropy expressed by elongation of grains along a certain direction. The structure anisotropy leads to anisotropy of mechanical properties. The simulation is redoubled for multi-layer production by the several reasons. Firstly, there is an accumulation of micro or macro defects at each fusion boundary. Then heat dissipation changes over the time due to heating of the product. And further, there are geometry-dependent items such as changes in a product cross-section and strategy of parts build-up. As a result, the product has anisotropy of structure and properties along the X and Z axis. In the transverse Z direction, the plasticity and viscosity can be by 2 to 4 times lower than in the longitudinal X direction. And apart from this, samples cut in the same direction, but from different places will have different properties. Fortunately, metallurgical technology has a remedy against anisotropy, and the heat treatment is the remedy. Most alloys require heat treatment to obtain the expected strength and plastic characteristics. Thus, a complete heat treatment is required, which includes homogenization of to obtain an isotropic structure and quenching with tempering or engine to obtain the specific mechanical characteristics. So we considered the technical possibility of introducing the direct laser deposition to the manufacturing plants. However, equipment and film material for DLD are still quite expensive. That's why we need to evaluate economic aspects for production by conventional and DLD process. The incoming data of investigated parts are presented in the table. Based on this data, the production cost could be calculated. Production cost consists from material cost and outlays of labor intensity. In its order, the outlays of labor intensity consist from amount of standard house and its cost, and several taxes which are addition coefficient of standard house cost. As can be seen, material costs for conventional manufacturing process are several times lower than for DLD method. On the other hand, labor outlays for DLD is lower than for conventional methods. The DLD production costs almost equally consist material cost and labor intensity outlays. And for production cost for conventional technology consists by 95% of labor intensity outlays, and material cost is just 5%. In addition, the material utilization rate in various production processes is more important than the cost of raw material per kilogram. In our case, material utilization rate increases in further order: auger, hemisphere, propeller, body. Low material utilization rate corresponds to prolongated machining. As a result, high labor outlays and material losses are inherent for the product. In a first approximation, material utilization rate can be used as a criterion for evaluating the feasibility of replacing traditional technology to direct laser deposition. The efficiency of replacing conventional technology by DLD is production cost of DLD divided by production cost of conventional technology. And if we compare that results with material utilization rate for conventional technology, we have dependency shown in the picture. Red line means equally in production costs. How can we see from the given regularity the replacement of parts produced with material utilization rate of 75% and higher by casting and insignificant machining to DLD method is not reasonable. The economic effect of transition to DLD process increases with increasing of removed material from the billet or with increased technological operation amount. So in conclusions, the direct laser deposition is an advanced production process which have a big potential of integration into many machinery industries, including shipbuilding. The process in computing technology leads to change in approaches to design and structure. This extends the space of using mathematical computational methods during creating new design and products under specific quality criteria. With help of computational technologies, it's possible both to design products of required geometry and to create optimized structures of lower weight, ensuring operability under loads. Subsequent heat treatment is necessary to obtain an isotopic structure and sufficient mechanical properties for the most of products obtained by direct laser deposition from metals. The economic effect of replacement conventional manufacturing process to DLD increases with increasing of removed material from the billet or with increasing technological operations amount. And that's all, and thank you for your attention.
Рудольф, огромное спасибо, очень интересный доклад. Коллеги согласились, что это прорывные технологии, и у нас они, в том числе в университете, благодаря Глебу Андреевичу, благодаря его сотрудникам, вот, в том числе и Рудольфу Корсмику, очень интенсивно развиваются. И наши корпорации, там, я боюсь ошибиться, но, по-моему, вертолетостроительная корпорация и другие корпорации заказывают. То есть практически это не просто университет, а это и производственная площадка. Ну, вы, наверное, знаете, что компания Damen тоже вырастила гребной винт, он немножко большего диаметра, он сделан из стали, и он имеет сплошные цельные лопасти. Там проведена сертификация через Germanische Lloyd, и, насколько я знаю, может, Рудольф меня поправит, сейчас наш винт, выращенный в Корабелке, также готовится к процессу сертификации через соответствующее классификационное общество. Скорее всего, это будет Российский морской регистр судоходства. Правильно, Рудольф, или что-то не так сказал?
Ну, тут более комплексная задача, то есть непосредственно винт, который мы вырастили, он испытывался в оптовом бассейне в Крыловском центре, соответственно, прошел испытание. Звездочка успешно выращивает подобные винты. Вот. Касательно аттестации и сертификации в морском регистре, у нас сейчас как раз запускается активная фаза сертификации лазерных технологий применительно к судостроению, как раз с целью их последующего внедрения. Тут не только аддитивные технологии, но и вообще технологии сварки, наплавки и родственных процессов с использованием лазерного излучения.
Спасибо, это очень интересно и перспективно. Спасибо большое, Рудольф. И это, в общем, идет в развитие того, что нам Глеб Андреевич Туричин рассказал в своем первом докладе о применении аддитивных технологий в судостроении. Большое спасибо, коллеги. Значит, мы сейчас можем... Да, но у нас есть раздел комментарий сопредседателей сессии. Профессор Туричин сейчас уехал у нас, поэтому если есть какие-то комментарии от нашего индийского коллеги, контр-адмирала Карунандитхи, то, пожалуйста, мы готовы слушать эти комментарии по этой сессии. Сессия индустрии 4.0.
Thank you very much. Let me sum up the first and the last paper, which are more or less similar. The processes are more or less similar. The additive technology, the first paper, focused on how to improve the production processes, adapting to the latest technology. Although the technology, metal deposition, is not new. This is as old as 1980, but the process has now matured. And Professor Klibb has rightly brought out the direct laser deposition method, which has been amplified in the last paper also, with particular reference to the propeller. This technology with the maturing, the direct laser deposition is now possible with, as stated by Professor Klibb, on a number of materials, including some alloys, which is, I would say, to what was there in 1980s. What was inhibiting so far is adapting this technology was the less volume of requirement in the case of shipbuilding industry, the size and material, and the regulatory approval. Now, all these things have been overcome, and as brought out, the bulbous bow, propeller, rudder, etc., as applicable in the ship design, are better suited for adopting this technology, and including, and he has the first paper as well as the last paper has demonstrated the quality, how the quality control has been maintained, how the shrinkage have been controlled. Probably the last paper also elaborated on the thermal expansions and how it is to be controlled. And Finally, of course, the last paper brought out how the heat treatment process has to be done to seamlessly bring out the quality into the final product. Yes, the cost drastically reduces as against the labor intensive in the conventional process. The cost has drastically come down. The material wastages come down. And my question is to Professor Kleb is, I understand that the repeatability in the quality assurance, quality product is not maintainable. I have a doubt on this. As far as the second paper is concerned, Mr. Vinith, with respect to the small and medium scale industries, how the IT infrastructures have been, latest technologies have been dovetailed into their design and manufacturing processes. And he has elaborated mainly how the cloud computing has brought down the administrative, the production design cost, and going by the adapting the Linux open source software, it has further come down in the case of the overall project cost. He has explained in detail about while using these modern technologies for collaboration as well as for design and cutting down on number of the production design cost, how the entire design data is backed up and how it is how the security is ensured, that outside intruders do not hack the data. I have only one question to him, that when it comes to the manufacturing, I'm not sure whether the company Precision Power Products has got the manufacturing facility in-house, PCBs, etc. Because these are available, it could be easily outsourced with ensuring the equal quality for the final product. Let me come to the third very interesting subject of autonomous shipping. This is a very interesting subject, and I would like to spend a little more time in this. Autonomous shipping, as I understand, the process started sometime in 2017 in Russia, and it has come to a mature stage of the final voyage trials, which is expected to be completed by November. It's a good progress. I'm not sure that while the entire effort in autonomous shipbuilding, including the regulatory authorities, the processes, IMO agreeing to all the whether for operations and for maintenance and rescue, the IMO process has concurrently taken place. I'm not sure only one thing about how the operations of the autonomous ships can go along the constrained coastal navigation, which is something which has to that repeated trials and the experiences will have to be built into the autonomous ship software. I have only one, as per the reports coming available in the open media, it's predicted that at least there will be 2,000 vessels would be operating by 2025 across the globe. And the industry by the time also would have matured. The operators would have also matured. I have only one question, that in a major ship operation, where with the crew intensive ship operation, there are two extreme conditions which are critical. One is total blackout and major fire. How these things are being addressed in the autonomous shipping process, that is MAS, Maritime Autonomous Shipping System. How these two, there is total blackout when there is a total power failure and when there is a major fire. How it is these two things are addressed. Otherwise, I enjoyed the presentation. It was technically very intensive, and thank you for giving me an opportunity to some of the proceedings.
Professor Kirill, can the companies made presentation respond to the question very briefly? Is that okay? Mr. Vinit, are you online?
Александр, вы на связи?
Yes, sir, I'm online.
If you could, will you briefly answer the question which was put up by the chair regarding your manufacturing facilities related to PCBs?
Sure. Please do.
Briefly, please. Thank you.
Please do.
Vinit, go ahead.
Can the question be repeated? Actually, my app had crashed, so I had to re-log in. So I could not get the question.
Yeah, I'll tell you. See, your company, Precision Power Products, you have brought out in the final few slides the in-house manufacturing facility for the PCBs.
So,
if the entire exercise is for cost reduction, I mean, including the capital investment, the PCB manufacturing facilities are available in abundance, even in Aurangabad or Pune or Bombay, elsewhere. Couldn't you have thought of outsourcing this, because this is already mature technology?
Sir, the manufacturing of PCBs is outsourced. In my presentation, I was talking about an SMT line where we assemble the PCB. We don't manufacture it. It's a manufactured PCB in which we assemble the components.
Even this is also outsourced, isn't it?
Yes, sir, it is outsourced. But at Aurangabad, we have got a facility that has been sanctioned by the government as an electronic cluster. So where there's a huge subsidy in getting the machines required for this PCB assembly. So there our cost has drastically cut down.
This is what I expected. Okay, thank you.
Yes, sir.
Thank you.
Thank you, sir.
Admiral Karunanidhi, add just a very brief comment. In the defense manufacture, there are certain PCBs which are so critical for performance that they need to be done in-house. For example, our company has to do certain PCBs in-house because we really can't outsource them because of the criticality. That's a brief comment from my side. Thank you.
Thank you, Srikant.
Would you like other questions, Admiral Karunanidhi, or shall we pass on to the administrator?
Basically, I have posed only one question for the autonomous shipping.
I think we'll deal it offline if it's okay with you.
It's okay. It's okay.
Yeah.
Thank you.
Professor Kirill, can you take on and pass on to the next session, please? Thank you.
Коллеги, пожалуйста, вопросы, которые возникли или будут возникать по презентациям с российской стороны, вы можете послать мне в письменном виде или авторам. Мы вам дадим их имейлы, они вам ответят. Потому что некоторые уже отключились и сейчас занимаются другими делами. Спасибо большое за комментарии. Большое спасибо адмиралу Карунанидhi за очень глубокие замечания по этим всем докладам, содержащие не только анализ, но и определенную критику и сомнения. Это то, что и нужно для научно-технической дискуссии. И, конечно, большое спасибо за подключение коммодора Дэшмука, который тоже комментирует и даже отвечает на вопросы, заданные автором индийских презентаций. Дорогие коллеги, мы, наверное, можем считать, что сессия 4.0 у нас исчерпана, и с вашего разрешения я перейду к сессии номер 5. Это Maintenance, Repair and Operation Session. И здесь у нас сопредседателями являются коммодор Бхаркава и, можно включить, и доктор Георгий Муру. Сможете его, да, подключить. Ага. Если вы разрешите, я два слова скажу о Георгии.
Профессор Кирилл,
Кирилл, да?
May I take the opportunity of introducing Commodore Bhargava?
Sure, let's start with you. Yes, Commodore, please do. And then I'll characterize Muru.
Good afternoon, ladies and gentlemen. It is my utmost honor to introduce my valued colleague and my Indian naval colleague also, Commodore Mukesh Bhargava. He is alumni from Kharagpur, and he has had a very illustrious career in the Indian Navy. His prowess in the technical knowledge and adaptation of technologies has been proven with his training in Russia on various high technology platforms. He has been a founding member of introducing those platforms in Indian Navy for the various operations and their successful utilization for the operational purposes. He has been a valued member of L&T, his retirement from the Indian Navy, and he did an unsurmounted contribution to the progress of the defense vertical of Larsen & Toubro. He is a very valued person in that particular organization. He is also very much interested in development of the industry as such, especially the SMEs. And he is the chairman of the CIR's Western region. And with that capability, he has made very special efforts to develop the SMEs in and around that region, integrating them into the defense sphere, giving a boost to the Atmanirbhar Bharat policy. Once again, a warm welcome to Commodore Mukesh Bhargava, who is the session chair for the session 5. Thank you.
Thank you, Shrikant, for your kind words. Can we proceed with the session, or we wait for Professor Kirill to introduce Gregory Muru?
Да, я скажу два слова про Георгия Муру. Покажите слайд. Можно? Я хочу показать его фотографию. Георгий Муру закончил училище, вы знаете, высшее училище имени Дзержинского, военно-морское. Он является капитаном первого ранга, то есть он служил на флоте. В настоящее время он возглавляет 51-й конструкторско-технологический институт судоремонта военно-морского флота. Он также является профессором нашего университета, Санкт-Петербургского государственного морского и технического университета. Сам его институт очень много занимается различными нормативами, стандартами, касающимися технического обслуживания и ремонта. И практически это основной институт по судоремонту для военно-морского флота Российской Федерации. Сам Георгий Николаевич, я боюсь, что он сейчас находится на важном совещании, поэтому, когда у него появится возможность, он, наверное, несколько слов скажет для нашей аудитории. А сейчас мы, наверное, можем перейти к докладам сессии номер 5. Да, я, конечно, хочу тоже поблагодарить коммодора Харкаву, который является сопредседателем, известный уже нам по предыдущим нашим сессиям и контактам офицер, известный коммодор. Первый доклад на повестке дня у нас делает Центр судоремонта «Звездочка».
Before that, Professor Kirill, I would just like to give a little brief about today's session. Today's session we'll have...
Welcome, конечно. Пожалуйста, извините.
Спасибо большое. Today's presentation, we have 4 presentations being planned with the presentation from yesterday's modern technology in shipbuilding. We'll have Garden Reach Shipyard presenting on the modern technology in shipbuilding by Commander Bhaskar Sen Gupta, General Manager. And thereafter, we'll follow with the MRO presentations. But before that, a few words about the shipbuilding. It's a very important day today and yesterday that we are discussing the nation building through shipbuilding between India and Russia as a prelude to the visit of President Vladimir Putin to India. Ladies and gentlemen, you'll be surprised to know that India has the history of maritime shipbuilding that dates back to 3000 BC, before Christ. It would be maybe a surprise to our Russian colleagues as well. The first shipyard was developed in Lothal in Gujarat in the 3000 BC, where they started making ships and basically the sailing ships. And there they developed also the technology for naval architecture, including the radars, planes, and the propellers. The shipbuilding moved from India to UK, United Kingdom or England, because from the wooden ships which were being built in India, the technology moved to the steel and the steam engines. From the shipbuilding has gone around over the last centuries and millenniums, from UK to United States, and from United States to Europe, from Europe to Japan, and Japan to Korea, and Korea to now China. And it is to be seen whether the shipbuilding and the majority of the shipbuilding can come back to India from where it actually started nearly 5,000 years ago. It would be interesting for our Russian colleagues also to know that the Roman Emperor Alexander, when he invaded India in the year 326 before Christ, after he got defeated in war, his army could not go back to Rome, and it was a king of Punjab who donated 800 ships to take the Alexander's army back to Rome. So that is the history of shipbuilding in India. Well, coming back to the modern times, we have the shipbuilding moved to absolutely a new dimension, and we've been hearing about it since yesterday. And since this session is going to be, other than Commander Bhaskar Sen Gupta, we'll have mainly the MRO, or maintenance, repair, operations, and overhaul session. I would like to mention that modern shipbuilding, in spite of the changes that are taking place, is poised to move into the digital era or the digital shipbuilding. That is what has been speeded up. It was any case going to happen, but it has got speeded up with the pandemic, which has made the digital technologies as the backbone for all development. The ships are highly complex platform, as we all know, and the shipbuilding industry is capital intensive. That means it requires huge revenues, and the orders for the ship are cyclical in nature. You have the alternate feast and famines. That means you get big orders and there is holidays for a long time. That makes the MRO, or the maintenance, repair, operations and overhaul, a very important line of business for the shipbuilding industry. And as we know, a normal life of the ship could be anything from 25 to maybe even 50 years. And this makes the maintenance, repair, overhaul a very important revenue stream for the shipbuilding industry. If we consider the through life cycle cost, or the cost of ownership of a ship, what amount is spent on the MRO could be anything from 3 to 3.5 times the cost of procurement of a ship. So if the ship cost is 25, the MRO cost could be 75. And that is what makes the MRO a very important sector. It's an evergreen business and different from shipbuilding in terms that the timelines are much shorter. It is more labor intensive, and that makes India as a very prominent player, and in partnership with Russia, which has a huge design engineering capability, it actually makes a very good mix of Indian and Russian. Further, as I mentioned about the introduction of technology in the field of MRO, we have now Indian industries which have come up with, we had a presentation on Industry 4.0, but I would like to share with our Russian colleagues that there are many shipyards in India who have actually transformed into Industry 4.0 and now going to 4.0 plus and Industry 5.0 with introduction of artificial intelligence, machine learning, Internet of Things, industrial Internet of Things, and the 3D printing and other technology that were mentioned. MRO is also a very quick revenue generator, but it has challenges of inventory management from the supply chain. And most important factor for what we feel about the MRO is the timely completion of the repairs and quantification of the scope of work, because it has a tendency of the creep of scope. And that's why the shipyards would do well to properly articulate a clause to ensure that any creep of scope for MRO is well accounted for. India, as we know, straddles the Indian Ocean region, or the only ocean which is named after India, which is a major shipping route, 7,000 kilometers of the coastline, and all the major shipping routes for India, as it was mentioned yesterday, 85% of the trade goes through this. As a revenue earner, it is projected that MRO would be close to about $12 billion worth of business. And if we just compare with a very small country, Singapore, it has nearly 20% of that business, as against India, which has got just 1% share of the global MRO business. That is what makes a huge opportunity for MRO business for Indian shipyards. And in the Maritime Agenda 2030, which was also talked about yesterday, there is a projection and there is a directive from the government of India to increase this 1% to 10% by the year 2030. That is where we have the huge scope of the MRO. If a shipyard is involved in the shipbuilding and also gets into the MRO, it takes care of the cyclical nature of the shipbuilding, because during the lean period of the shipbuilding, the MRO activities can be the revenue generator. It is seen also as an extension of the shipbuilding business. And as I mentioned, there is a huge scope for the technology induction, digitalization, I mentioned about it. The big support for MRO comes in the form of the 3D model, or as we call it, the digital twin, which is the new technology being introduced in most of the Indian shipyards today. It would be a big support for the shipyards who have built the ship to also get into the MRO, because the shipping and shipping out routes can be planned for faster execution of MRO. And it is also going to be a big help in terms of the inventory control and the digital thread of linking up all the supply chain, as well as the spares that are there for the through life support of the ship. The knowledge of design, decisions and the compromises that are made during the shipbuilding process can be leveraged for improving the MRO and the process of bidding for MRO, where the shipyards who have built the ship can actually be much more competitive compared to the other bidders. The as-built 3D model can improve the quality and also drastically bring down the TCO, or the through life cost of ownership of the ship. I would just like to mention few of the challenges which are also there, and I'm sure that the two eminent speakers that we have today are going to be covering it. One of the major challenges that what I foresee is managing the current inventory as well as the future shipyards, because the future shipbuilding would definitely be using much more modern technology, where the MRO would also be required to manage ships which are 20, 30 or 40 years old. So how do you manage this? Two types of ships would be a major challenge for the shipyard getting into MRO. Most important aspect is data and the information. And how do you control all the data which is there? I mentioned about the digital twin, but the digital twin would be requiring information coming from different organizations, from different vendors, from different designers, and all of that to be integrated into one package. And whether the digital twin would be able to do that is going to be a challenge for the shipyard getting into MRO. And the last challenge that I can see is reusing this information into the different kind of formats. The CAD processes which are used by the designer or the repair organization could be different. If the same shipbuilder gets an MRO, it will have the advantage of the compatibility of the CAD platforms. Otherwise, this could be another challenge. So I would just like to sum that we overestimate the value of technology in the short term, but underestimate the value of technology in the long term. And that is going to be a hurdle that the shipyard getting into MRO would have to face. We'll start with the presentations now. And I would request, because of the paucity of time, we are already running 45 minutes late. I would request the speakers to restrict themselves to 12 and maximum 15 minutes. And I would like to interject the moment the time is over. We start with the first presentation, Commander Bhaskar Sen Gupta, General Manager, Garden Reach Shipbuilders and Engineers. Bhaskar, your presentation, over to you.
Thank you, sir.
Я бы хотел поблагодарить коммодора Бхаркаву за исключительно глубокие ремарки, которые он сделал, за очень интересные и полезные вещи в части реализации цифровых технологий, в частности, как, например, Digital Twins будут работать с предприятиями, у которых есть установившиеся, можно сказать, традиции прошлого времени. Очень интересный был экскурс также в историю индийского судостроения, думаю, полезный для нас в России, потому что действительно, что это началось так давно, наверное, мало кто знает. Это замечательно. Поэтому огромное спасибо коммодору и большое спасибо коммодору Дэшмуку за его представление коммодора Бхаркава, потому что они коллеги, они работали много лет вместе, и в простых словах самое главное было сказано о этом замечательном специалисте и офицере.
Thank you, Professor Kirill. Очень много я изучил в вашем городе, Design Bureau Rubina. Поэтому я тоже благодарю вас.
Да, я надеюсь, что специалисты Рубина вас тоже слышат. Вы знаете, что они недавно совершили подвиг, и что их аппарат «Витязь» покорил Марианскую впадину.
Да, я знаю об этом. Bhaskar, over to you. You can start the presentation now.
Сейчас, не секунду. Да, сейчас будет вот этот, вот, Бхаскар.
Can we start, sir?
Yeah, go ahead, Bhaskar.
Commodore Deshmukh, sir, Commodore Bhargav, Professor Kirill, distinguished panelists from SMTU, Russia and India, a very good afternoon. It is a great pleasure to present our endeavors of Industry 4.0 to this August forum. Indeed, it's a pleasure all the more because while we also have a great history, Russia has a great history from Tsar Peter the Great, almost 300 years of shipbuilding history they have. So it is a great pleasure to present a paper to this great maritime community. We have taken some baby steps in Industry 4.0. And so without any further ado, I shall hand over to my colleague Amber, who has been spearheading our Industry 4.0 initiatives within Garden Reach Shipbuilders and Engineers. We will try to keep it short as the Commodore has directed, 12 to 15 minutes. Over to you, Amber. Please go ahead.
Thank you, sir.
I have a small request. Since we have to join another webinar for IDEX around 2:30, so immediately after our presentation, if the questions can be made, that would be very nice. Okay, Amber, please go ahead.
Okay. Thank you, sir. So I'll start with a small request that I will be switching off the video because of low bandwidth. Okay. So today, our presentation is, the agenda of the presentation is leveraging digital tools towards Shipyard 4.0. And my presentation will cover 7 areas, starting with a glance into the history of Industrial Revolution and the key elements of Shipyard 4.0, followed by 5 use cases of Industry 4.0 toolsets implementation at GRSE, covering entire spectrum of shipbuilding. The first industrial revolution began at the end of 18th century with dawn of water and steam powered mechanical engines. With second revolution came the construction of first steel ships and diving boats. Third revolution brought integration of IT tools with machines to further automate the production process like CNC, robotic welding, etc. And the present fourth industrial revolution enables a digital shipyard environment by utilizing capabilities like cyber physical system and Internet of Things. This slide in a nutshell shows the key elements of Shipyard 4.0 like automated robotic processes, virtual and augmented reality, big data, Internet of Things, secured cloud, virtual modeling, and cyber security. Now let's have a glimpse of Industry 4.0 tool sets implemented or under development at GRSE. For case 1, PDM PLM implementation and compartment inspections using virtual reality. With advancement in market-ready platforms available globally, GRSE has seamlessly transitioned to various modern design and simulation softwares. Leveraging this, we are in the process of implementing a PLM software, Siemens Teamcenter, customized for shipbuilding. Teamcenter would be integrated with AvivaNet for 3D model transfer and would act as a single window for all sharing and approval activities, bringing multiple stakeholders at a single platform. With Mazgaon Dockyard at Mumbai, GRSE at Kolkata, Navy headquarters at Delhi, as well as local stakeholders like customer rep at MDL and GRSE, production team, QA team, etc. for the P-17 Alpha frigate project. Teamcenter will have an active workspace-based embedded portal for viewing the latest drawings and 3D models. In addition to AvivaNet, PLM would also be integrated with other platforms like SAP, MS Office, email servers for seamless transfer of data. Compartment lineout inspection is the first stage for beginning work in any compartment, which earlier was used to be carried out physically, only after complete hull construction. The physical inspection required finalization of compartment layout drawing, which usually happened at an advanced design stage. This led the whole process to be highly time sensitive and highly prone to work. Now, with advent of digital LOI of compartments using 3D model in Navis work, shared remotely with customer reps through Team Center, LOI could be carried out independent of construction stage of vessel. Any comments observed during LOI are marked on the model and shared by to design team by the inspection agency. With integrated construction concept, the user could now share the S3 and S5 stage drawings for LOI commencement. This in turn saves time, eliminates requirement of physical LOI, and drastically reduces rework possibilities. GRC is also equipped with virtual reality lab, which utilizes IC.IDEO software for converting the Aviva 3D model into a virtual navigable walkthrough of the compartment. The VR lab has features like real-time kinematics, virtual navigation support, and Aviva support. A short GIF of how the walkthrough of the compartment would look like to the user is shown here. Here we can see a 3D model at S3 or S5 stage, which was reviewed by customer, Indian Navy. The falling of cableway with trunk was identified during digital LOI and marked on the model. This is another example where falling of items were identified and marked on the model during LOI and shared back with the design team. Now, case 2, online inspection monitoring system. Now, Indian warship building is a complex project-based industry which has an increasingly competitive market demanding optimum quality and timely delivery. There is always a raging battle between quality and time during ship construction period. Thus, a rule-based framework was developed in-house at GRC to capture the quality activities of shipbuilding, in turn capturing the project progress and maintaining a robust vendor base. This tree shows a typical snap of various stages of shipbuilding inspections. The inspections are grouped into various sequences depending on the component being inspected. The sequence of inspection stages is repeated for thousands of discrete components of hundreds of systems, and an inspection note is generated each time. The amount of physical inspection documents thus generated ranges somewhere around 100,000. That too only for one vessel. OMS is an industry standard open source IT platform developed indigenously with 5 key objectives. First, a single point for recording and retrieval of all inspection activities. Second, an effective user interface with no restriction on number of users while adherence to strict defense cybersecurity norms. Third, project progress monitoring. Fourth, aiding to create a robust vendor base. And fifth, leveraging data analytics, benchmarking, and AI capabilities. OMS is designed to replicate the as-is process of inspection activities to an optimized workflow. It has been developed with an open source developmental stack, hence it is independent of OEM for customization requirement, as Java developers are easily available in the IT industry. Inspection reports are generated in OMS in a fillable PDF format, secured with PIN, unique for the user to which a job has been assigned. Each transaction in the system is done with individual secured login ID. The system framework distinguishes the role of various departments for data creation, data feeding, maintenance, and inspection transactions. This is a snapshot of the platform, OMS, where the fillable PDF can be downloaded by the user. A system-generated PIN governs the security of this PDF. All necessary inspection parameters, including drawing attachments, are available for the user to see prior inspection. Another sample of OMS generated editable PDF report in which inspection stakeholders can input their comments, but only in their marked areas to record their observations. These secure and fillable reports can be taken offline from the system to the site, filled, and then at a later time uploaded in the system at user's convenience. OMS also tracks the inspection history and shows the user status of history of inspection in a color-coded manner for ready reference. This helps for the user to have a quick summarized glance of the previous inspection status of each offered component prior going for inspection. Another key objective of the platform is project progress monitoring. A dynamic pictorial representation of the project, as seen in the framework, is automatically generated as various transactions are undertaken in OMS, giving a comprehensive depiction of current project progress. Comparing the earlier manual system versus digital OMS for inspection, time for inspection report endorsement has reduced from up to 72 hours to within 24 hours. Traceability has become completely paperless and report can be easily retrieved digitally. Progress tracking of project has become digital based on OMS. Vendor rating is now done based on the system generated objective parameters like number of offers, rejections, etc. OMS is further complemented by a quality control report based inspection report generation. QCR consists of checklists for individual inspection stages, a defined format for parameters recording, as well as recording observations during inspection. More than 100 QCRs have been formulated, encompassing complete shipbuilding inspection stages. Now, where earlier reports were used to be generated in a blank piece of paper with common format for all stages of inspections, OMS generates the inspection report in QCR format specific for individual inspection stages. Here, a comparison of earlier blank report versus QCR based OMS generated report is shown. Case 3, implementation of AI enabled radiography weld evaluation platform. Typically, during the construction of a medium size defense vessel, around 3,000 to 4,500 radiography shots are taken per ship. Single use RT films are utilized in the traditional radiography processes, the processing time of which took about 6 to 8 hours, and the wait time for production from performing the test to getting the results ranges around 2 days. As you can see, the whole process is tedious, time consuming and subjective. As a part of digital radiography process, computerized radiography scanner has been implemented at GRSE, which utilizes reusable imaging plate or IP for radiography exposure, which are then scanned, analyzed and erased for reuse by CRS. The latent image of weld joint captured on IP are converted to digital signal. The phosphorus based IP can be reused up to 1,000 times. This is a sample digital radiography image of a weld joint scanned on CRS. The user can also mark the weld defects identified on the digital RT image and share the evaluation results with other stakeholders. This shows the complete digital radiography process, starting with RT of weld joints using IP, followed by scanning of IP in CRS, processing of scanned latent image of weld joint, automated weld defect recognition using AI tool, and finally, the film gets erased for reuse. Presently, the AI tool set for step number 4 is being developed at GRSE. Automated weld defect recognition software, or in short ADR, is an AI and ML based platform for analyzing the digital RT images to identify, classify and give the verdict for acceptance or rejection of weld joints based on boundary conditions. A complete digital radiography process would result in overall reduction of downtime, improved productivity, an objective rule-based evaluation process, and overall cycle time reduction from 2 days to 2 hours. Case 4, system trials leveraging digital tools. This is a case study of engine trials which were carried out during pandemic restriction without OEM's physical presence. Usually, these are the steps followed during commissioning trials of engine system. While step 1 to 3 can be easily done by an engineer with a basic knowledge of system, OEM assistance for step 4 to step 6 is crucial. However, with the global restriction of traveling due to pandemic scenario, OEM's physical presence at shipyard was impossible. Nevertheless, the engine trials were undertaken at GRSE with OEM on remote assistance. The steps for trial was commenced on board by team of shipyard who trained themselves using tools like virtual simulator. Any error encountered during the operation would be simulated by OEM on their 3D model of the system to guide the yard team for eliminating them. comparing the conduction of system trials earlier versus leveraging digital tools. Preliminary inspection like cable checks could be done with digital drawings available on the secured devices in place of requiring hard copy of drawings. Software installation could be done by control engineer with the help of 3D model and VR training, where earlier OEM physical presence was mandatory. Also, safety devices check for the system could be done using simulator kit by technician trained for error simulation using virtual simulator, which earlier was carried out by OEM themselves. Case 5, inspection using augmented reality. As a novel project, GRSE is developing augmented reality tool sets for onboard inspections. This would allow the user to carry 3D design models on digital devices like tablets and other handheld devices. The 3D model can be overlaid with the current site conditions with 1:1 scaling. This would enable the user to easily understand the complex drawings and perform visual inspection in a digital environment. The AR tool sets would eventually limit paper uses for drawings and data required for onboard inspections, would allow the attending surveyor to access digital part lists and drawings on the tablets, would provide the surveyors with digital tools for measuring dimension between AR model and actual site conditions, and also would fasten the overall inspection process due to intuitive AR view at site. With these development and implementations of Industry 4.0 tool sets, as highlighted in this presentation, GRSE has embarked its voyage towards a digital shipyard environment. Thank you.
Thank you very much, Bhaskar and Amar, for an excellent presentation on Industry 4.0. I will now move to the next presentation, which is starting of the MRO. And the first presentation on the MRO would be...
Спасибо большое за этот замечательный доклад. 4.0 сейчас очень модное направление. Я в 2019 году был на конференции, которая называлась почти так же в Нью-Дели. Она была Nation Building through Shipbuilding. И убедился в том, что Индия находится на переднем крае вот этого направления. Там обсуждались и Digital Twins, и интернет вещей, которые у нас мы называем Internet of Ships, и виртуальная интегрирование, virtual integration, и вот эти все вопросы я тогда понял и вижу сейчас на основании этого доклада, что Индия очень быстро движется по этому направлению, которое позволяет сделать более эффективной нашу отрасль. Если мой коллега разрешит, я хочу объявить следующий доклад. Это доклад...
Yes, sir. Please go ahead, Professor Kirill.
Можно, да? Можно? Разрешаете, да? Значит, это доклад Центра судоремонта «Звездочка». Их подразделение, которое называется Центр пропульсивных систем. Автор доклада, руководитель этого центра Сивков, а доклад будет делать главный инженер Олег Викторович Рохин. Дима, проверьте, есть у нас Олег Викторович? Олег Викторович, вы есть, да? Олег Викторович, вы на связи?
Да, здравствуйте, я на связи.
Пожалуйста, Олег Викторович, вы готовы, да? Можно включаться?
Да.
Значит, доклад называется, ну, условно называется «Технологии изготовления грибных винтов». Ну, Олег Викторович поправит, может быть, название.
Уважаемые коллеги, здравствуйте. Меня зовут Олег Рохин, я работаю главным инженером Центра пропульсивных систем. Позвольте мне свой доклад сделать без презентации. Для меня большая честь выступать перед вами людьми, поставившими свою профессиональную жизнь, посвятившими свою профессиональную жизнь судостроению, потому как уже неоднократно звучала мысль, что эта отрасль промышленности концентрирует в себе все другие ее направления. а следовательно, технологии других отраслей и неизбежно связанные с этим проблемы и, конечно, успехи. Тема моего доклада не изменена, звучит как технология изготовления грибных винтов. Рассказ о любой технологии изготовления деталей делится на несколько глав. Грибной винт не исключение. Сначала поговорим о конструкции грибных винтов, затем об основных технических требованиях, перечислим группы материалов и типы заготовок, которые используются для изготовления винтов. Назовем основные методы обработки поверхностей и завершим разговор перечислением этапов технологического маршрута обработки грибного винта, состоящего из нескольких операций. Итак, конструкция. Грибной винт представляет собой систему лопастей, расположенных на равных углах относительно друг друга и закрепленных на втулке, которая у нас называется с вами ступица. Число лопастей современных грибных винтов колеблется от 2 до 11. Поверхность лопасти, которая при переднем ходе судна воспринимает упорное давление протекающего потока, называется нагнетательной. Противоположную поверхность лопасти называют засасывающей. Конструкции грибных винтов разделяют на сборные и цельные. По габаритам винты разделяют на крупногабаритные, куда попадают диаметры от 2,5 метров, и малые габариты до 2,5 метров. Основные требования к винтам зависят от их класса точности, и представлены эти требования в международном стандарте ISO 484. В национальном стандарте России он также есть, это ГОСТ 8054. Конечно же, правила международных морских регистров также имеют требования к качеству изготовления грибных винтов. Всего 4 класса точности грибных винтов. Самые точные винты – это особый класс, затем следует высший, средний и обычный. Требования по поверхностям лопастей, по шероховатости требуют их шлифовки, вне зависимости от класса. Материал для грибных винтов должен отличаться высокой коррозионной стойкостью, упругостью, прочностью, хорошими литейными качествами, поэтому грибные винты изготавливают из бронзы, латуни, нержавеющих сталей, а также используются титановые сплавы, конечно же, чаще в военном кораблестроении. Изготовление грибных винтов из углеродистой стали тоже существует, допустимо, но в целом нецелесообразно из-за низких эксплуатационных качеств таких винтов. В незначительном количестве применяются также пластмассовые грибные винты и композитные конструкции. В качестве заготовки преимуществом безусловным обладают все-таки отливки, выполненные из металлических сплавов. Для лопастей грибных винтов есть два метода обработки. Это фрезерование и шлифование. Применяют, как я уже говорил, для всех классов. Применение фрезерования лопастей для обычного класса грибных винтов из бронзы в целом нецелесообразно при качественном изготовлении отливки с небольшими припусками. Фрезерование выполняется на многокоординатных специализированных винтообрабатывающих станках с числовым программным управлением. Так, и если вкратце, как я обещал в начале, давайте я перечислю основные операции типового техпроцесса изготовления грибного винта. Начинаем мы техпроцесс с распределения припусков, нашей отливки и разметкой технологических баз у заготовки. Эта работа выполняется с помощью средств измерения, коим является специализированное оборудование под названием шагомер, либо бесконтактные координатно-измерительные машины тоже, безусловно, находят свое применение при изготовлении грибных винтов. На нашем предприятии это лазерный контроль с помощью API-трекеров и фотограмметрическая система также используется при контроле грибных винтов и распределении припусков. Следующая операция – обработка измерительных технологических баз, коими являются поверхности ступицы. Это токарно-карусельная операция. Затем размечаем дополнительные технологические и измерительные базы. Вновь возвращаемся на разметочный участок и размечаем шагомером следы осевых лопастей. Размечаем контролируемые радиусы сечений, точки замера толщин на этих сечениях и точки замера шага сечения. Далее фрезеруем нагнетательные стороны лопастей. Используем специализированные для этого используем специализированные винтообрабатывающие многокоординатные станки с ЧПУ. Далее восстанавливаем разметку, контролируем шаг обработанной нашей нагнетательной поверхности лопастей. Кантуем заготовки. Важная операция, если речь идет о крупногабаритных винтах. Эта операция требует внимания, кантовочной площадки, грузоподъемного оборудования, если речь, повторюсь, идет о крупногабаритных винтах. Далее фрезеруем засасывающую сторону лопастей, фрезеруем контур лопастей, кромки на фрезерном винтообрабатывающем станке. Снова кантовка, чтобы иметь полный доступ к основной поверхности, которая является нагнетательная, и контролируем геометрию лопастей повторно. Выполняем шлифовальную операцию, снова выполняем разметку и контроль геометрии. Затем переходим к балансировке грибного винта. Для этого требуется балансировочный стенд. Предварительно рассчитывается масса страгивающего груза, устанавливаемого на наружном диаметре грибного винта, на кончике лопасти. Выполняем расчет площади лопастей и ее расположение на засасывающих поверхностях лопастей с учетом их толщины и допуска. Выполняем дополнительное фрезерование. Эта операция практически всегда выполняется, так как при первой балансировке грибного винта в большинстве случаев мы с вами столкнемся с дисбалансом, и его устранение требует дополнительной фрезерной операции, требует дополнительного расчета площади поверхностей лопастей, которую необходимо вновь фрезеровать. Затем окончательная обработка отверстия ступицы, ее торцев, окончательный контроль качества, предъявление регистру и упаковка для отгрузки потребителя. Подводя итог, можно сделать такие выводы. Первое. Конструкция всех грибных винтов либо сборная, либо цельная. Сборная мы отдаем преимущество винтовой паре, то есть специальные повышенной прочности болты крепят лопасти ступицы. Бывают, конечно, сварные варианты, но мы стараемся таких вариантов решения избегать. Сварка обладает своими, так скажем, недостатками и требует особо тщательного контроля, в том числе со стороны инспекционного общества. По габаритам винты крупногабаритные либо до 2,5 метров. Наше предприятие выполняет изготовление любых габаритов грибных винтов. Основные требования находятся в общем доступе. Это международный стандарт ISO 484, правила регистров, и национальный стандарт ГОСТ 8054. Материалы для грибных винтов: коррозионно-стойкие стали, бронзы, спецсплавы, в основном преимущественно титановые. Для лопастей грибных винтов есть два метода обработки: шлифование либо фрезерование, либо их комбинация. Основные этапы технологического процесса требуют специализированного оборудования, специализированных станков, организации участков шлифования, участка балансировки и, безусловно, требует высококлассного опытного персонала. В заключение можно еще сделать такой посыл. Помимо звездочки, изготовлением грибных винтов занимаются и другие предприятия, в том числе и в России. Конечно, и вы, уважаемые коллеги, можете увеличить количество их производителей, создавая производство в Индии. Тогда вам потребуется освоить все перечисленные этапы изготовления, обеспечить производство всеми необходимыми ресурсами, высокопрофессиональным персоналом, зданиями, фрезерными, расточными, карусельными, специализированными станками, средствами измерения. Необходимо будет создать участок ремонта шлифования, балансировочный участок. Насколько это разумно? Ответ, конечно, можно получить, разработав бизнес-план. Но я возьму на себя смелость советовать, что при разработке бизнес-плана, мне кажется, следует рассмотреть вариант создания предприятия в кооперации со звездочкой, которое имеет компетенции в изготовлении крупногабаритных грибных винтов, ледовых классов, в том числе ледокольных. Тогда у вас появляется возможность обеспечивать потребность своих предприятий, своих верфей в таких грибных винтах. Спасибо за внимание.
Thank you, Mr. Oleg Trofen, for your presentation on production technology for the screw propellers. And thanks for the
Очень подробную и интересную презентацию.
Capabilities. It's my profound pleasure now to invite the next speaker, Captain Siba Kumar Patnaik, Independent Senior Advisor. He'll be speaking on the MRO challenges and solutions. A few words about Captain Siba Kumar Patnaik. He's an alumnus from IIT Kanpur and has also done his post-graduation from IIT Kanpur. It's my pleasure and honor that we joined the Navy together, and he's been always the topper of our course, and that is something which we have all been looking up to him. In his naval career, he was known for his expertise on the noise, vibration, and the repairs of what the previous speaker has spoken about on the propellers and the shaft line. After doing a very illustrious career in the Navy, he moved on to join the company which I joined after him, which is Larsen & Toubro, and he's been heading the shipbuilding and the marine business development in the L&T for more than a decade plus. His other appointment has also been moving on from L&T shipbuilding. He moved on to Reliance shipbuilding, where he held the position of a senior president and drove the various multiple projects for shipbuilding that were there. Presently, as I know, Captain Patnaik is working as an advisor with IIT Mumbai and trying to mentor the young engineers towards defense and aerospace technology. With these few words, I would hand over to Captain Patnaik, who will be talking about MRO challenges and solutions. Siba, all yours.
Thank you, Commodore Bhargav, for your kind words. It's good afternoon, ladies and gentlemen in India, and good morning to Moscow or Russia, or is it the noon time? I think we are about 2.5 hours ahead of Russia. So yeah, it's a good morning there. So we are running out of time, as I was told by the chairman. And I will stick to this precisely to 15 minutes of my presentation on the MRO, maintenance, repair, and overall with respect to platforms. Before I start off on the MRO, its challenges and solutions, let me slightly give an overview of a salient difference between new construction shipbuilding and the MRO. It is very important for us to know. And thereafter, I will also dwell upon the MRO of a kind of warship vis-a-vis the MRO of a commercial ship. They are also significantly different. We must try to understand this. Very major points. and then it will have a commonality of challenges when you are undertaking MRO, and there will be possible solutions. And I will leave some thoughts behind at the end of my presentation so that we can dwell upon, because these new constructions and repair and refits are, when it comes to technology, knowledge, it's a never-ending process. Now, to start with, I will start sharing the screen. Is the screen visible?
Yes, sir. Yeah, yes, yes, you can go ahead, Shiba.
Yeah.
Just put it on the slideshow mode.
Yeah.
Yeah, that's okay.
It's okay. It's taking time. Yeah. So when it comes to shipbuilding, I think I need to put it on a. Yeah, I will. Is the slides visible?
Yes, slides are visible, but it's not on the slideshow mode.
Yeah, if I put it in the slideshow mode, probably certain portions getting chopped off. All right, I will try and manage that.
You keep clicking for the subsequent ones to come. We are on the total digital solution. Yeah.
So we coming to shipbuilding, as you all know that since it's a digital era and we have gone ahead digitalizing the entire shipbuilding process. Briefly, let me explain to you. In a new construction shipbuilding, you have system schematics to start with, and from the system schematics, you start developing a 3D model. I put it as CATIA V5 because I like CATIA V5. You can have anything else. You can have a Tribon, or you can have a Aviva Marine or Aviva Net, any kind of a 3-dimensional tool. From the CATIA model, you start developing this model and start filling up the compartment. That is in a new construction process, when the drawings are there in front of you, you start filling up the compartment. And when you start filling up the compartment, you start doing the interference analysis. You can do a walkthrough. You can see the pipe layouts, cable layouts, and equipment installation. And you can again go from a CATIA 3D model to a virtual reality lab, wherein the user is made to sit over there, the customer is made to sit over there and give his remarks with respect to operability, maintainability, and accessibility. So OMA, and thereby you correct your model before you start productionizing your shipbuilding process. This is how the entire shipbuilding process goes through. And once the model is frozen, more or less frozen, then you go into PLM. You can use any of the PLM tools. You can use a Team Center. You can use Windchill, whichever is available to you in your shipyard. From the PLM, once you migrate to PLM, you can generate production drawings. You can generate bill of material. You can generate complex jigs and fixtures required for shipbuilding process, and you can also figure it out what are the shipping in routes and shipping out routes. With this, once this is developed, you go in for extracting the production drawings and bill of material. As you can see here, I can give another glance of system schematics to modeling to progressive build-up of compartment. Just now I told you. And now you are from the 3D, you can generate automatically the production drawings and bill of material, which can be sent to the site for production purpose. This is the error-free production which takes place at the site. Now coming to MRO, I will just give you a workflow in general. Most important thing is the defect list, what you receive as a shipyard from the user, from the ship. And this defect list analysis is very important. I have configured hull engineering, electrical, and W&S, weapons and sensors. We have two categories like underwater package and afloat package. You must analyze it very carefully. As Commodore Bhargav mentioned in his opening remarks, that defect list analysis and understanding of the defect is very important to start the MRO. Otherwise, you will have what he mentioned as the creeping effect. You must be very careful. And after you analyze the thing, you must also see spare parts aggregation. You have to consolidate the spare parts. You have to have a proper inventory management. You go to have a tie-up with the OEM. You go to have a tie-up with the material organization in terms of getting the spares, components, sub-assemblies available with you. Otherwise, you may land up in very critical problems. Also, you must also identify tools and tackles. I was telling in my previous slide, for the new construction shipbuilding, jigs and fixtures, tools and tackles are very important, both for ship construction as well as for MRO. For example, for propeller removal, for shaft pullouts, main engine lifting, gun mount repairs. So you have to have the tools and tackles for which you need to identify. And next point is very important. As-built 3D model generation is very important. When you actually construct a ship, you develop a 3D model, and when the ship is commissioned, through its life cycle, 10 years, 15 years, 20 years, 25 years, a lot of changes do take place, both in the form of equipment and systems. And therefore, the initial drawings do not remain as it is after 15 years when it comes for refit. Therefore, as-built 3D model generation is very, very important. Otherwise, you will end up in problems. Then there comes the repairs in the shipyard workshop or in OEM premises, or you offload to subcontractor. Then comes the testing and tuning in the workshop, and thereafter you have onboard fitment with the principle of last out and first in. The ones which are taken out last will be brought in first. On that basis, then they carry out the test and trials. Now, the basic difference between new ship construction and MRO. New ship construction is more structured. Drawings are verifiable, drawings are verified. The sequencing is more systematic and better control. Whereas in MRO, it all depends upon what kind of defects you get, what kind of, the as-built drawings, what you generate, because a lot of changes take place through the operational cycle. So therefore, I'm using a word called randomness. A lot of randomness is used in case of MRO because it all depends upon the nature of the defect. Technology is well established in case of new construction, whereas in MRO, it's more like firefighting and more challenges are there. I'll come to the challenges a little later in my 2 slides. Equipment undergoes FATs in case of new construction, factory acceptance trials, so no much problem of spares. Whereas in case of MRO, it is largely dependent upon spares. Therefore, the certainty and uncertainty of spares is very, very important. Major equipment in case of new construction, the installations are well sequenced. Here in case of MRO, there is a ship side cutting. There is a possibility because of overall of major equipments, which may lead to a lot of distortions. And in case of new construction, lastly, deformation and distortions can be well managed, whereas it's a big challenge for MRO. Coming to MRO, there is a bit of a difference between MRO of a warship and MRO of a commercial vessel. Warship is definitely, as we all understand, is more challenging because of space constraints and because of sequencing. Therefore, sequencing in case of warship is very important. Sequencing of dismantling, sequencing of reassembly is very important. In case of commercial vessel, it is comparatively easy. PPM routines and defectations are pretty rigorous due to the role of the ship. In case of commercial vessels, the routines are little relaxed because most of the defectations of at least the major and medium equipments largely go to OEM for major overhauls and top overhauls, buttoning up, and they bring it back. Warship, the systems are very complex, whereas in commercial vessels, the systems are pretty straightforward. In warships, again, for the MRO, you have a hull, you have an engineering, you have electrical and electronics, you have W&S, that is weapons and sensors, and aviation. So many fields you go to look into. Whereas in commercial vessels, you probably have hull engineering and electrical, no W&S, more or less. Warships, you have a thin hull structures, more challenges because any rectification would involve distortions. Whereas in commercial vessels, no major problem as such. Warships, lastly, comparatively lesser problems on tanks. But here in MRO, when you do a commercial vessels, being a huge tanks, tank cleaning and gas free is a major challenge. It is just briefly, just to have an idea of various kinds of MROs. You have a, in naval parlance, you have a short refit, normal refit, medium refit. You have a dry dock MRO specifically, which is called essential repairs and dry dock. You have a component MRO specifically for an equipment MRO. You have a system MRO, or for that matter, you have a modernization or an upgrade kind of an part of MRO, where we call it A's and A's, alterations and additions. So various kinds of MROs are there. It's a matter of knowledge. Coming to challenges, which is very important, Commodore Bhargav also mentioned in his opening remarks, accuracy of the digital print is the hallmark of the success of the MRO. The more accurate your digital print, the more will be the ease of doing the MRO. That's why my second point is, if the digital print is all right, you will have a good effect as far as the sequencing of dismantling and reinstallation is concerned. And unshipping from the ship side cutting and soft patch cutting, and therefore it may result into consequent distortions. You got to be very, very careful. Timely availability of spares and components, I have told you earlier, this is also one of the big challenges while carrying out MRO. Skill set, another core issue where skill set for workers and supervisors, that is, as far as I'm just given an example of main propulsion alignment. A lot of skill set is required for this. Weapon alignment, skill set, hull machinery working, trials, etc. Specific skill sets are required, which are to be, therefore, imparting skill set through proper training to the workers and supervisors is one of the big challenges for shipyards undertaking MROs. Expertise in piping, trunking, and cabling. Expertise for main and auxiliary machinery and its overhauling. Then repair workshops are required. That is why Commodore Bhargav mentioned it is capital intensive. When you have to create workshop for hull equipment, you have to create workshop for engineering equipment, you got to create workshop for electrical equipment. Initial investments will be definitely higher in this aspect. Then another challenge is testing and tuning of weapons and sensors. It is a separate section. If the shipyard has to undertake, you have to have capabilities of repairing, testing, and tuning of W&S, weapons and sensors. Creation of testing facility. You have a high pressure systems, you have underwater valve testing, you have hull equipment testing, you have electrical equipment testing. You have to create special separate facilities for this. Similarly, you have main shafting. If the shaft pull out takes place as a part of MRO, you have to have a two-nest check, facility for two-nest check. Balancing of propellers, both static and dynamic. ICCP facilities, you need to create this. System buttoning and system integration is a big challenge as far as the MRO of a ship is concerned. Onboard pressure testing for air pressure lines and hydraulics. And lastly, cold checks and hot checks on board on completion of the refit before the ship goes out to sea is also one of the challenges. Solutions. First solution, as you can anticipate, obtain a digital footprint of machinery and systems after the pre-refit trials are over. Before the ship enters any refits, any repair, you must obtain correct digital footprints, and accuracy of the footprint is very important. Number two, based upon the defects, sequencing of dismantling needs to be ascertained. first out, last in should be the basic principle of dismantling. 3. Major equipment overall, it need to be removed first and sent to the OEM, because OEM has got his own cycle time for any top overall or for any major overall. 4. Mustering of essential spare parts, components, sub-assemblies. This must be consolidated a priori. That I have already told as a big challenge, but you must do this so that inventory management becomes your one of the primary tasks while carrying out MRO. 5. Strict monitoring of outsource activity. The ones which you are outsourcing, you have to see the timely delivery and the quality. 6. Repair facility. That means you must have minimum dependence on the new construction workshops because the lines are separate. Excuse me. So the new construction lines, and there can be a dependence on basic facilities, but MRO, the repair and repairs sections need to be as independent as possible with respect to shipbuilding and MRO. 7. Commercial vessels, the more structural repairs will be envisaged. So you go to focus more on commercial equipment, structural repairs, and the equipments, once they are shipped out, they go to OEMs for overhauling. Next is continuous training of workers and supervisors. I've already mentioned to you, it is of paramount importance. Creation of dust-free environment for electrical components, high pressure systems, weapons and sensor systems. You need to create an environment, dust-free environment for this. System integration on board, very critical. Cold checks and hot checks can be done parallelly to cut down on time. Similarly, DG trials, hull equipment trials also can run parallelly for parallel to main propulsion assembly. Lastly, I have mentioned 40, 30 and 30 repair philosophy. That is 40% you do afloat work, followed by 30% in the dry dock. Balance 30% is post dry dock, including trials. This is my thought process. Shipyards may have a different percentage of repair philosophy, but why I projected this is just food for thought. You can have different percentages. 40, 30, 30 seems to be an ideal way of looking at it. Additional thoughts before I conclude. Shipbuilder, like Commodore Bhargav also mentioned, a shipbuilder, when you're building ships, it has got highs and lows. So when there is a lean period, MRO generates revenue. So it is always preferable if the shipbuilder also enters into MRO service. This is advantageous, and it is even more advantageous if the shipbuilder builds the same class of platforms. So therefore, the repair and refits become that much easier. Number 3, few basic workshop facility could be extended for ship repair. That means there can be some commonality between the new construction ship workshop and MRO workshop. 4, the shipyard also when you are doing the digital scan or digital tracking, I've just given an example of a Faro scanning machine. You can have any other digital tracker machine wherein you can have an entire digital tracking of a compartment. That makes the life so much easier while you are putting back things after repairs. Similarly, you can also generate reference points for onboard calibration. Lastly, commercial vessels where large hull structures, large hull plate renewals are taking place, one can think of use of a robot that would improve accuracy and speed. Therefore, ladies and gentlemen, I will conclude ship repair and ship refit in a very subtle manner. I'm saying that it's a murky game. Yes, it generates a lot of revenue, but you need to have a sound planning. Sound planning is a must. Similarly, timely logistics support is necessary, without which the MRO will run into problem. This particular digital model that you are generating it, as-built digital model what you are generating, would determine the sequence of dismantling and reassembly it should be carefully implemented. Otherwise, again, you will run into problem. Lastly, first time right, this culture should be the motto of the MRO space. And if any rework is there, it will tantamount to time overrun, effort overrun, and finally cost overrun that we must avoid. That is all, ladies and gentlemen. I finished. Thank you very much for giving me an opportunity to share my thoughts for MRO's challenges and solutions. Thank you.
Thank you very much, Captain Patnaik, for a very lucid presentation on opportunities and challenges, solutions for MRO. We come to the end of this session, and it's my great pleasure to invite Commodore Shrikant Deshmukh, Senior Vice President, SAN Group and ELCOM Group. Shrikant is like Captain Patnaik, also my coursemate. We joined the Navy together, and it's my profound pleasure to introduce him to you. He's the organizer of this program, so actually he doesn't need any introduction. Everybody knows Commodore Deshmukh, but for the benefit of others, I would just, I don't have his biodata with me, but I can just say that
я хотел бы сказать два слова. Извините, что я выхожу, просто некоторые дела возникли.
Please go ahead.
Значит, я бы сказал несколько слов перед тем, как вы расскажете о своем коллеге, коммодоре Дешмуке.
Yeah. Please go ahead. Please go ahead.
Can I switch off the presentation, the previous presentation? So
yeah, it's gone. It's gone.
So, dear colleague, dear co-chairman, I'd like to say, хочу несколько слов сказать о замечательном человеке.
Вас не видно. Давайте я вас.
Нет, сюда.
Хочу несколько слов. Найдите, да, ниже. Давайте. Он там в конце где-то. Вот здесь, давайте на полную катушку. О замечательном человеке, коммодоре Дешмуке, я с ним познакомился давно, когда он приезжал в Петербург, обычно вместе с Валентином Валентиновичем Романовым, который представляет САН Групп. Я знаю о коммодоре как о очень знающем, квалифицированном и пользующемся большим уважением человеке. Ну, его биографию вы знаете лучше меня, она здесь на английском языке представлена. Я просто хочу сказать, что коммодор сыграл огромную роль в организации нашего с вами вебинара. И, по сути дела, название этого вебинара – это тоже его заслуга. Поэтому я приветствую еще раз коммодора и желаю ему успешного выступления, в чем я не сомневаюсь. Спасибо.
Thank you very much. I think in the paucity of time, since your CV was already flashed, Shrikant, if you permit, we can start with the presentation because we are already 30 minutes over time. Over to you, Shrikant.
Yeah, thank you so very much. Good afternoon, ladies and gentlemen. Session chairs, co-panelists, and friends. Thank you for this opportunity for presenting some views on the use of modern technologies in ship maintenance. The ship maintenance has assumed a great importance as brought out by Commodore Bhargav, and the presentation will be shown as reflected on the slide, ending with the challenges and the way forward. As Francis Stokes had said, whenever your preparations for the sea are poor, the sea worms its way in and finds the problem. These words aptly signify importance of the effective maintenance for the ships. It is undeniable that with technology advancing in leaps and bounds, discerning customers have demanding greater efficiency in operation of platforms and equipment at reasonable MRO, that is maintenance, repair, overall cost, to remain cost competitive in the market. As financial crunch has started biting the whole shipping world, the dictum, if ship is worth acquiring, then it is worth maintaining efficiently, has assumed a new meaning. Accordingly, need for the efficient MRO operations has become an imperative. The maintenance of the ships has got many facets, which Captain Siba brought out, but just for the comparison, for a warship, we range onboard maintenance down to various short refits, normal and extended refits, etc. Comparatively then, if we go to the civil side, they have got what we call the plain maintenance schedules, followed by the yearly schedules. And finally, the overall, which we take a major overall on the outsource basis. The dry docking, unscheduled maintenance, and sea trials and acceptance are very, very important facets in the maintenance operations. As we know, the maintenance operations are time-consuming and expensive. Further, the ships in harbor amount to the lost revenues. Thus, efficient planning and execution of maintenance activities is extremely crucial. It is important to note that the trends of neglecting maintenance for profits is detrimental to the well-being of both the ship and its crew. In today's world, which is witnessing increasing sea trade, use of bulk carriers, tankers, super tankers, LNG carriers, etc., as well as the offshore oil explorations, fishing and ocean wealth extraction operations, Antarctic operation, there has been commensurate increase in the ship maintenance requirements. It has been forecasted that the ship's MRO market would grow at a CAGR of 8%. With budgetary constraints, customers have been forced to demand a cost-effective maintenance with minimum downtimes. All of these demands have forced technological advancements in the ship MRO technologies. The figure on the slide, I'm sorry about the quality, but because of the size, it was limited. It reflects on the complexities of the ship's MROs as such. There have been many advancements in the ship's MRO sector, wherein the technologies are trying to bring down the complexities and make MRO operations much more efficient, less time consuming, and consuming less cost. Let us now examine these technologies one by one. The maintenance efficiencies enhancing tools cover the technologies like big data analytics, which has simplified analysis of voluminous defects and the repairs data to uncover hidden patterns, unknown correlations, ambiguities, and other useful information. This has, in turn, helped in efficient planning and execution of maintenance activities. Use of smart sensors, which cover a very wide range of devices, these are used to measure the physical environment in which vessel may be operating, the characteristics and the state of the vessel. Sensor technologies, the Internet of Things, has facilitated real-time monitoring of various systems, leading to efficient maintenance. Autonomous systems is a rapidly expanding technology which has allowed the marine industry on improving safety and efficiency by taking people out of the 3D, dirty, dangerous, and dull jobs. These systems are maturing now, addressing the cost, robustness, endurance, and regulatory challenges. Use of robots, which are remotely controlled, is performing now very complex tasks, either supervised, collaborative, or fully autonomous. The emerging technologies have revolutionized the marine maintenance services, and the robotics is becoming an integral part of the tasks, especially those conducted in severe working environment. Blockchain and the distributed ledger technology, that is DLT, have a great potential for ships maintenance. DLT has helped in improving supply chains by giving better visibility, connectivity, and savings as a result of distributed ledger adoption across the supply chain, thus bringing down the cost of maintenance, the point which was emphasized both by Commodore Bhargav and Captain Patnaik. Then the advanced materials. The desirable functionality such as environmental sensing, self-cleaning, self-healing, enhanced electrical conduction, and the shape modification has been facilitated by developments in nanomaterials, delivering maintenance benefits in the commercial shipping, naval, and ocean space industries. The advanced manufacturing is another facet. 3D printing of spares and future developments such as 4D printing, which is in the offing, coupled with nanotechnologies and robotics, are expected to lead to savings in the maintenance costs. The human augmentation techniques made considerable advances in terms of advancing both physical and cognitive human capabilities, which include power-assisted suits and exoskeletons that enable efficient movements, bringing accuracy and reducing maintenance times and, in turn, the costs. Higher broadband speeds, these have enabled many emerging IT-based technologies to revolutionize shipboard maintenance and extend equipment life. Efficient maintenance of shipboard engines and machinery is reducing expenditure for ship owners and vessel operators by extending the lifetime of machinery. This has also helped in formulating smarter maintenance strategies, dry dock planning, and more effective maintenance of onboard systems. The virtual engineering or the augmented reality have offering now remote support services which are being enhanced by using augmented reality and the virtual engineering tools. Ship operators now receive real-time advice and technical support for their assets, thus eliminating the need for coming to a harbor to an extent. Artificial intelligence and machine learning, these technologies have resulted in greater benefit for vessel owners and manufacturers. This has become possible by quick and efficient data analysis by the experts for cost-effective, predictive, as well as on-condition maintenance. Digital 3D twin. This was a facet which was brought out both by Commodore Bhargav and Captain Patnaik. The vessel maintenance has drastically improved by use of 3D models of the ships, also known as the digital twins. Here, a 3D model of a ship design is maintained at the same time as the actual vessel is, enabling owners, repair yards, and onboard engineers to visualize the condition of the ship through its lifetime. The smart maintenance portals, the analyzed data now streams from machinery sensors, predictive maintenance, information, and online advice are now being stored on online portals for data storage and multi-stakeholder access, thus bringing in the efficiencies and reduction in the maintenance costs. I would like to reiterate here that most of the technologies which I spoke about are already in operation. However, it would be important to examine the actual status of some of the latest technologies in the ship's maintenance sphere. The actual status of some of the technologies is quite promising, and virtual engineering and augmented reality is now being put to use on board and ashore. Artificial intelligence and the machine learning is still in a developmental stage and is under experimental use, but is showing commendable promise in the ship maintenance arena. Digital 3D technology is being used by class and the forward-thinking ship operators. Virtual reality is currently being tested by class and first training courses under the development. Smart data portals, we have more advances in this area coming up for the use. Thus, we can conclude that what we have been talking about is a reality here and not a pipe dream. However, as we all know, technologies never come into being without their own challenges. Some of the complex challenges in the ship maintenance sector, which could be equally applicable to many other sectors, are as shown. Cyber attacks, as all the systems what we spoke about are mostly data-based, cyber attacks would be a real threat. Use of efficient data protection systems could be a solution or rather a necessity. The bandwidth limitations, unreliable connectivity is also an issue. Wide use of 5G technologies could be a solution, but these technologies also have their own issues which need to be sorted out first. Availability of skilled manpower was a point which was very succinctly brought out by Captain Patnaik. And here it is important to note that as we progress, the man behind the machine still matters. Thus, protecting the systems using artificial intelligence from damage by the natural stupidity is a very big challenge. Better training and skilling of manpower would be a solution to overcome this problem. Finally, in conclusion, I would like to say that it is evident to us by now that the need for the cost-effective maintenance of ships is not a dream, but a reality, and we have to adapt it to as fast as possible. It is important that all the stakeholders in the space accept this reality and act upon it. Many modern technologies are now available for enhancing the maintenance efficiencies and bringing down the time and cost. Efficient utilization of the new technologies should be given due priority, even if the initial cost may seem to be high. Better cybersecurity systems, reliable high-speed internet connectivity, and infrastructure and training of imbibing skill development are some of the basic requirements for garnering the benefits of modern technologies in ship maintenance arena. Earlier they are adopted by us, better it would be for all of us. We as a group have always done our bit and will continue to strive for supporting India's need for ship maintenance and the Atma Bharat initiative. In this space, if we could collaborate with our Russian friends, we will be more than happy to assist and work along with them. Thank you for this opportunity. Jai Hind.
Thank you, Shrikant, Commodore Shrikant Deshmukh, for an excellent presentation on the modern technology and also covering the challenges which are there in the MRO sphere. I would now like to request my co-chair, Dr. Gregory Mro, the 51st Design and Technology Center from St. Petersburg. Are you there, Dr. Mro? I don't see Dr. Mro over there, so I'll try to quickly sum up, if I may be permitted. Professor Kirill, can I sum up? Okay, I'll go ahead with a quick summing up.
For this interruption, okay.
Yeah, Professor Kirill, can I sum up, or Dr. Mro is there, Gregory Mro is there for summing up?
We still have one presentation from Center for Shipbuilding and Ship Repairing Technologies, and if you don't mind, we'll call upon CTSS, and this would be Boris Loginov, Deputy Director of their company, which is in charge of international cooperation, technical cooperation. And the title is по-английски, по-русски, и называется этот доклад «Предложения ЦТСС по сотрудничеству с Республикой Индия в области проектирования, изготовления, ремонта, испытаний и сертификации судовой трубопроводной аппаратуры». Слышно меня, да, коллеги?
Yes, we can hear you.
Так, пожалуйста,
Yeah,
Борис Логинов. Борис, пожалуйста, заместитель директора внешнеэкономической фирмы АО «ЦТСС».
Добрый день, господа. Учитывая ограничения по времени, хотел бы представить краткую презентацию о деятельности нашего Центра технологий судостроения и судоремонта в области судовой трубопроводной арматуры и возможностях сотрудничества между Россией и Индией в рамках концепции Make in India. Центр технологий судостроения и судоремонта, кратко ЦТСС, ведущий технологический центр судостроения России, представляет собой многопрофильный научно-производственный комплекс и обладает статусом государственного научного центра. Имеет в своем составе научно-исследовательские лаборатории, конструкторские и проектные подразделения, производственные мощности, необходимые для изготовления изделий судового машиностроения. По комплексным проектам АО «ЦТСС» построены десятки крупнейших заводов и уникальных объектов России и за рубежом. В том числе, как вы видите, в период с 1992 года по настоящий момент по линии военно-технического сотрудничества Центром технологий судостроения и судоремонта был создан ряд предприятий и объектов для обеспечения строительства, ремонта и базирования кораблей и подводных лодок в Республике Индия. В таких городах, как Визакапатнам, Мумбай, Карвар, Качин, Джамнагар. Разработка и производство судовой и корабельной арматуры нового поколения является одним из важнейших направлений деятельности АО «ЦТСС». Конструкторское бюро «Армаз», как структурное подразделение АО «ЦТСС», является главным разработчиком и базовым предприятием в области проектирования, организации и внедрения в серийное производство судовой трубопроводной арматуры для нужд ВМФ России, военно-технического сотрудничества и гражданского судостроения. Кроме того, оно осуществляет авторский надзор за производством арматуры на всех предприятиях судостроительной отрасли России. КБ «Армаз» является также признанным изготовителем и поставщиком судовой арматуры для нужд военно-морского флота России. За годы деятельности конструкторского бюро по разработанной документации и имплементации внедрены в серийное производство более 20 тысяч типа размеров арматуры. Для реализации научно-исследовательских и опытно-конструкторских работ КБ «Армаз» имеет в своем составе конструкторские подразделения производственной мощности, а также уникальный сертифицированный исследовательско-испытательный комплекс, обеспечивающий проведение всех видов испытаний судовой арматуры. Принимая во внимание большой опыт в реализации совместных проектов с индийской стороной по линии военно-технического сотрудничества, АО ЦТСС считает целесообразным в рамках реализации концепции Make in India предложить создать на территории Республики Индия производство по изготовлению судовой арматуры. Для создания производства ЦТСС готова оказать техническое содействие подготовке конструкторских кадров для возможности проектирования различных видов судовой трубопроводной арматуры и разработать руководящие методические документы по ее проектированию. Разработать проектно-сметную документацию для создания производственного комплекса. Выполнить поставку специального технологического и общепромышленного оборудования, а также оснастки ЗИП к нему. Обеспечить монтаж, пусконаладку, ввод в эксплуатацию поставленного оборудования. Провести обучение индийских специалистов об эксплуатации поставленного оборудования. Оказать услуги по гарантийному и послегарантийному обслуживанию оборудования. Оказать техническое содействие в создании современного испытательного лабораторного комплекса в целях обеспечения проведения различных испытаний изготовленной арматуры. Разработать соответствующую нормативно-методическую документацию как для сертификации серийного производства судовой арматуры, так и сертификации готовой продукции. ЦТСС также готова осуществить поставку ЗИПа, рабочих комплектов деталей, узлов, конкретных типов судовой арматуры для обеспечения ее ремонта на территории Республики Индия. Мероприятие, предлагаемое ЦТСС, позволит создать на территории Республики Индия уникальный центр компетенций в области производства судовой трубопроводной арматуры для ее проектирования, изготовления, ремонта, испытаний и сертификации. В данной презентации были кратко изложены предложения ЦТСС по сотрудничеству. Будем рады ответить на дополнительные вопросы и предоставить дополнительную информацию в рабочем порядке. Благодарю за внимание.
Большое вам спасибо. Мы примерно на час отстаем по разным причинам, поэтому, может быть, наш сопредседатель, замечательный, глубокий, аналитический человек, коммодор Паркава, скажет несколько слов в заключение. К сожалению, Георгий Муру сейчас уехал, поэтому, коммодор Паркава, пожалуйста, два слова скажите.
Thank you. Thank you very much. I will be very brief in summing up. We had a presentation from the Garden Reach shipbuilders on Industry 4.0, where they gave 5 use cases with regard to Industry 4.0. The first one being the PDM, PLM. The second case was for online inspection management. And the AI-enabled radiography was the third. Engine trials and commissioning was the fourth. And augmented reality inspection for onboard using the 3D model was the fifth. I think this was a very good presentation, compliments to the Garden Reach shipbuilders. Next, we had the presentation from Zoizdachka for the MRO category of discussion, where we had Mr. Oleg Trofin, who spoke about the production technology for screw propellers. And it is related to shipbuilding industry being related to all other industries. He spoke about the design of screw propellers right from 2.5 millimeter dia to 1 meter, and the various standards for Russian, international, as well as the various materials used like steel, titanium, alloy, as well as the composite, and the various advantages of that. He also spoke about the processes, the tolerances, and the step measurement using laser control, which was very well received by us, and I think there can be good potential for this. I only would request if we can have some inputs with regard to the special treatment for the propellers for the marine and the saline environment that the Indian Ocean and the Indian Navy ships operate on. If that can be given offline, that would be very good. And second question that I had for Mr. Trofin was, is it possible to transfer the technology for the propeller design to Indian industry and Indian companies? Because that would be a great step towards the self-reliance or Make in India. The third presentation we had with Captain Patnaik, who spoke about the MRO. He gave a comparison between the MRO of new construction and the MRO and the similarities as well as the differences between them. He brought out also the difference between the warship and the commercial shipbuilding. And he went in detail about explaining how a total digital solution could be a way forward, a digital twin or a 3D model, and how that can be of use for MRO. And he went about the various aspects of MRO, the details about the defect list, various parts of it, the special jigs, tools, fixtures required, the study of the 3D model that is built and the importance of that for undertaking the MRO, and the different types of MRO he spoke about, the dry dock systems, equipment, A's and A's. Then he went on to explain about the challenges with regard to the MRO, especially the digital model and its accuracy, the skill sets required, the overall of machinery being capital intensive, the testing and trials for weapon systems, machinery and propeller balancing, and of course, the skill sets that are required for undertaking the MRO. He also brought out the solutions, which included the as-fitted digital model, the sequencing of dismantling, major equipment overhaul, training of manpower, and he finally summed it up by saying the 40-30-30, which is the afloat dry dock and the post-dry dock induction trial, which would be a split of the total MRO work packages. Last but not the least, he gave us a food for thought with additional points, which comes out of years of wisdom and experience that Captain Patnaik carries with him. Lastly, we had an excellent presentation on the MRO technologies by Commodore Shrikant Deshmukh. He spoke about how the ship's maintenance is becoming important, how MRO cost can be brought down to make it an efficient for the ship owners. He spoke about the onboard maintenance, the SMP, MP, the various types of refit, and the dry dock schedule. Then, of course, he came to his main topic of the MRO technology. He spoke about the MRO market growing at 8% CAGR and the requirement of the minimum downtime, the technologies for MRO, big data, smart sensors, autonomous systems, robotic blockchains, advanced materials, advanced manufacturing, 3D printing, the importance of the broadband speed, the VR, AR, AI, ML, and of course the digital twin and smart maintenance portal for the data. Lastly, he covered the challenges which are there with regard to, since everything is data-based, the cyber attack would be a major threat, and the MRO executors need to take it into account. The limitation of the bandwidth could actually bring down the system. That is very important. And of course, he again reiterated what Captain Patnaik spoke about, the advantages of a skilled manpower for the MRO. Last but not the least, we had a presentation from JSC Shipbuilding and Ship Repair Technology Center. Mr. Oleg made the presentation from 1992 till today, number of projects that have been done, which include the recent one of 1135.6, the P17, P71, the EKM, and the various projects that have been successfully executed. He spoke in detail about the valves, fittings, and the pipelines, more than 20,000 design development that they have, and 35 test facilities. I would have only a few questions for Mr. Oleg that can be answered offline. whether they would be keen to share the transfer of technology for testing and cleaning, pipe cleaning, the pickling and the other requirement for design, as well as the documentation and setting up that infrastructure, which would be of great significance for Make in India going forward. Thank you very much, and over to Professor Krylov for taking.
Это вопрос к СТСС, как я понимаю. Вы можете очень кратко сейчас что-то сказать по этому поводу, а потом, наверное, поскольку вы знаете.
На сегодняшний день в СТСС разработано достаточно много технологий очистки всех практически систем, судовых систем, корабельных систем, поэтому мы готовы к сотрудничеству и готовы все свои те самые данные передать индийской стороне.
Спасибо большое.
Thank you very much.
Professor Kirill, can I have a minute before we hand over the session?
Sure, you always have priority in
Thanks
speaking,
for
please.
accepting our invitation and chairing this session. It's absolutely honor and pleasure. And Professor Kirill, I hope you'll appreciate my skill in bringing the three musketeers from the same batch onto this particular forum. Thank you so much. Honor and pleasure is mine.
Спасибо вам.
Pleasure is all mine.
Спасибо вам большое.
Спасибо вам большое.
Уважаемые коллеги, если больше сейчас по ремарке ни одной нет по пятой сессии, мы переходим к голубой экономике, Blue Economy. Я получил сообщение или предложение от профессора Раджу о том, что, по-видимому, какой-то из докладов будет снят для сокращения времени. Пока вот хочу представить, кроме профессора Раджу, сопредседателем сессии является профессор Вадим Гончаров. Это наш очень известный специалист с большим опытом работы и в Крыловском государственном центре, и в университете, и взаимодействие и с промышленными предприятиями, и с зарубежными партнерами. Специалист в особенности по полярным технологиям, по полярной навигации, правильно? Ну и по целому ряду других вопросов. Если профессор Раджу подскажет, какой из индийских докладов будет снят, мы могли бы двигаться дальше. Или вы будете по расписанию. У нас по расписанию стоит профессор А3. Будет его доклад или нет? Do you hear me? Okay.
Yeah, Professor Kirill?
Yes.
Yeah. Professor Kirill?
Yes.
Should we start?
Do we start? Yeah, we do start, but which presentation you leave in the schedule?
No, now Professor Atri will speak.
Okay, okay. Professor Atri, so can you announce him?
Yes.
Can you announce him?
Yes, good afternoon to everyone.
Это голубая экономика как парадигма устойчивого развития.
Good afternoon to everyone. And we have in this session focusing on blue economy. And we have four speakers. And the first speaker is Professor Viswanatha Atri, who was a chair in the Indian Ocean Studies at the Indian Ocean Rim Association since 2014. He is a lead editor with the Human Sciences Research Council of the Blue Economy Handbook of the Indian Ocean region. He has been visiting scholar at the University of California, Los Angeles, George Washington University. He participated in IORA's core group meetings and first ministerial conference on the blue economy and in the second Blue Economy Summit in January 2016. He is engaged in creating a network of scholars among IORA member states and dialogue partners on the blue economy. He was invited by World Bank as well as United Nations, where he has been propagating the relevance and how to develop a blue economy in a different parts of the world. And he has been advising to the 22 members of IORA on the issues related to the sustainable blue economy and about the process and pathways, making it inclusive, transformative, and as one of the major drivers of economic diversifications. And he has contributed to policy briefs, and that 2 briefs are related to blue economy. Now, may I request Professor Atri to speak on blue economy as a sustainable development paradigm, a case study of Indo-Russian economic cooperation. Over to Professor Atri.
Пожалуйста, профессор Атри.
Please unmute, sir. Sir, please unmute.
Hello.
Yes, sir. Yes, sir.
Yeah. So I'll be speaking on blue economy as a sustainable development paradigm, a case study of Indo-Russian economic cooperation. Here, I will be hurriedly dividing my presentation into 4 or 5 parts. In the first part, basically, I will be telling about the evolution of blue economy. And then basically, in the second part, we'll be talking about what are the emerging disciplinary metrics of the blue economy related with the definitions and other areas of blue economy. And then the third, basically, we'll be talking about the importance of shipping or shipbuilding in the blue economy. And of course, we'll be correlating this blue economy in the post-COVID-19 scenario. And in the last part, I will be trying to correlate the blue economy cooperation between India and Russia by taking the example of shipbuilding industry as well as other technological advancement. And I will here be bringing into the limelight the picture, the important event that has taken place, that at present, India is the chair of BRIC and Russia is the chair of Arctic Council. And the objective of the Arctic Council and the objective of the BRIC, as well as the objective of all regional economic groupings, including IORA, related with the sustainable development and how this blue economy can lead to the sustainable development of the region, as well as at a global level. So since 2009, there is a growing literature on ocean economy or blue economy. If you ask me to differentiate between the ocean economy and the blue economy, the only line which I will be telling that if you are utilizing the oceanic resources without taking into consideration the environmental degradation, that is using the oceanic resources unsustainably, but in blue economy, you take into account the sustainability. That is putting into picture the environment as well as other conservation and preservation techniques. So basically, that is the sustainable blue economy. And then the 2010, Guntar Pali published a book that is on blue economy. And since then, he made the presentation in 2009 in the United Nations also. There is a history of events in United Nations Conference on Sustainable Development in 2012. Basically, the 6th country pleaded for the case for ocean economy. Then in 2014, in Abu Dhabi on January 1st, under the auspices of UN Sustainable Development Knowledge Platform, the developing countries assembled and they agreed on a declaration on the blue economy. Then coming to IORA, where I served as chair in Indian Ocean Studies for 6 years, IORA adopted blue economy in October 2014 in Perth when Australia was the chair. And since then, IORA has made consistent effort to promote and understand the blue economy. And there basically, I will be very much brief in saying that 2014 to 2019, there have been a series of events. There have been 3 ministerial conferences on blue economy. The last one was in Bangladesh in September 2019. At present, Bangladesh is the chair of IORA. And on December 5th and 6th, 2019, IORA basically introduced the Blue Economy Working Group. And all the activities in IORA, which is a group of 23 member states and 10 dialogue partners, and Russia has recently joined as the dialogue partner of IORA. So from that angle also, there is a greater scope of collaboration between Russia and the other IORA countries, including India, in the field of the blue economy. It may be shipbuilding, it may be technical cooperation, because to me, it appears blue economy is an economy which is innovative in nature. So in that context, now basically the other important thing which is being debated in case of blue economy, that is related with the measurement of the size of the blue economy. And now the different countries, smaller countries have bigger share in the blue economy, larger country has smaller share in the blue economy. And that is one of the stylized facts that larger the country, the smaller is the share of the blue economy, and vice versa, although there can be exception. And the measurement of the blue economy is a very important issue as far as the developing countries, LDCs and SEEDs are concerned. The another important thing is, which is related with the blue economy, that is the financing of the blue economy. So blue economy needs huge financing. That is basically, if I can bring into the notice of the audience, that is the Green Deal. So the Green Deal issue has been tackled very efficiently by the EU. Then basically, European Union is a classic example where blue economy has been successful, but by and large, over the period of time, some sectors of the blue economy have registered decline in the contribution to their GDP due to the post-COVID. So now here the question comes before us, how or in what way the blue economy can help the countries all over the world in achieving rapid economic development, inclusive growth, and sustainable development. So one fact which basically emerges, that is the fact that there are certain sectors which have been very badly affected by the COVID-19, and shipbuilding is one of them. If I go by the latest report of UNCTAD on the maritime trade and shipbuilding, etc., published in 2021, that basically depicts that the short-term scenarios for shipbuilding is not very encouraging, because presently the GDP growth rates are down. But the glad thing is that after the COVID disasters in 2020, where most of the countries' GDP declined, all the countries, you see, according to the latest International Monetary Fund report of November 2021, the countries all over the world, they are registering growth rates, heavy growth rates, basically. For example, the growth rate of GDP in 2020 in Russia was minus 3.0, but in 21 it is 4.7, and in 22 it will be 2.9. In India, it was minus 7.3% in 2020. In 21, it is 9.5, and in 2022, it will be 8.5. In US, it was minus 3.4, and 21, it is 6.0, and 22, it will be 5.2. Similarly, in China, in 2020, the growth rate was positive 2.3. In 21, it is 8.0, and in 22, it is 5.6. So the point is that the major economies of the world, they are recovering. And shipbuilding or maritime transport, basically, they are key to the prosperity, key to the prosperity of the trade, etc. When the GDP of the country is growing, it will create a demand for imports. And for importing, basically, you need the ships. So basically, what I feel that there is a greater scope of cooperation between India and Russia. Although the fact is that 90% of the shipbuilding capacity, 80% of the shipbuilding capacity is with 3 Asian countries, that is China, Japan, and South Korea. But rest of the 10 to 15% shipbuilding capacity is shared by rest of the countries in the world. And here, if I bring into the content of Arctic Council, so there basically presently Russia is the chair, and one of the objectives of the chairmanship of Russia is to promote technical cooperation and opening new ship routes basically through the Arctic. And similarly in BRICS also, basically the focus is on agriculture, trade, banking, finance, investment. And in IORA, basically, we are also focused on sustainable development. So there is a link between India, Russia, and IORA. And when I talk about IORA, basically, we include some countries in Asia, some countries in Middle East, and most of the countries in Africa, because it is a group of 23 countries. So in that case, the important question in the post-COVID era is through multilateralism, multilateral cooperation, and cooperation through regional economic groupings. If we want to achieve sustainable development with sustainable blue economy, that goes through multilateral cooperation as well as evolving cooperation and collaboration between the regional economic groupings, whether it is BRICS, whether it is IORA, whether it is ASEAN, whether it is SAARC, whether it is EU, whether it is APEC. So that type of model basically has to be built between the regional economic groupings. So that is one thing which I would like to focus in my presentation. The second thing is, if you go by the latest World Bank report, 2021, data for better life. So the developing countries, the emerging countries, the LDCs, they lack in data collection. So the effort should be made in collecting data, in analyzing data, because you can have data without information, but you cannot have information without data. So the role of data is very important in the further economic development, rather sustainable development of all the economies, as well as implementing the blue economy between all the countries, whether it is bilateral cooperation, whether it is cooperation at regional level, and whether it is a cooperation at global level. The another important thing is the question of technology. That is basically accelerated technological change. How the emerging new technologies, artificial intelligence, robotics, 3D inventions, etc., can be shared within the countries of the world to promote and implement in the blue economy. Because blue economy basically refers to the exploitation of the oceanic resources within the exclusive economic zone of a nation. And that exclusive economic zone goes up to 200 kilometers from the shore of the country. So in that exclusive economic zone, the first issue is to identify the resources. What are the resources? The other important issue is to provide, to have the access to the latest technology. So the question of transfer of technology is very important, you see. If you ensure that there is a smooth technological transfer, and the countries who are rich in technology, they are ready to transfer their technology to the emerging economies, then only there will be the prosperity in the world and there will be the sustainable development through sustainable blue economy. But in that case, let me link this sustainable blue economy with the UN Sustainable Development Goal. There are 17 UN Sustainable Development Goal, which can also be attained through sustainable development of the blue economy. or the sustainable blue economy. So in that context, there also it is a question of multilateral cooperation. So the idea which is emerging, particularly that in sustainable blue economy, we have to adopt new business models, which of course are based on the assumption of scarcity to abundance, as well as basically the linking of the blue economy with the circular economy. Nothing is waste in the nature. And we also have to link the blue economy with the climate change. So the climate change, COVID, and the other issue basically have been identified by the IMF report, that is the emerging cryptocurrencies. These are three important things. And the another important thing is the question of financing the SMEs, because basically blue economy has been defined as strengthening the local communities, which is very close to the idea given by our Honorable Prime Minister, Atmanirbhar Bharat. So when we focus on blue economy, it is not the question of Atmanirbhar Bharat, it is a question of Atmanirbhar, self-reliant emerging nations, SIDS, LDCs also. And that path goes through blue economy, because by definition given by Guntar Pali, blue economy is the economy in which we are trying to use the local resources, local material, and we are also employing the local people, strengthening the local community. And the strength of the blue economy is that it provides productive employment, fruitful employment to the unemployed youth. The another issue in the blue economy is the question of bringing gender equality. So blue economy, basically, we have been emphasizing in IORA also, how does blue economy leads to gender equality? So that's it, one of the issue. And one of the focused area of IORA is also the women economic empowerment. So blue economy and women economic empowerment, and then the blue economy basically through digitalization leads to the trade and investment also. The question is, whatever we are producing from the oceanic resources, that product, whether it will be taxed, what will be the tariff, these are some of the issues which are not being raised. Although the World Customs Organization is trying to raise these questions, but nowhere basically we are raising these issues that when we will be producing the product from the established industries under the ocean economy or the blue economy and the emerging industries under the blue economy, what type of tariff structure will be having for the emerging new products coming from the ocean raw material, ocean resources. So that is basically the another important issue which needs to be highlighted, the integration of the blue economy, to which most of the country call the ocean economy, with the landlocked countries. So that is another issue. And then basically the most important is the mitigation of the climate change. You see that climate change basically, if the temperature is going up, if the water of the ocean is warming up, that creates a lot of problems. So how all these problems can be linked? So these problems basically, which are the problems or the challenges of the blue economy, which I say that basically the one of the challenges, the global warming. The another challenge of the blue economy, which applies to the member countries all over the world, all the countries, that some of the countries, they are very fast, they are very quick, and they are very successful in evolving the marine spatial planning, in understanding and introducing the marine spatial planning for the use of efficient use of oceanic resources. But most of the countries still, they have not started the marine spatial planning. So that marine spatial planning is another issue. Then there is a issue of ocean governance, the good governance, which is being tackled at various UN institutions, but still we lack basically all those things. And then basically the sustainable sustainability is an issue, and we should also focus on the carbon neutrality in the year 2050. So what are the plans the different countries are focusing with regard to the carbon neutrality? For example, European Union has made a plan having a Europe or European Union fully carbon neutral by the 2050. So in that context, basically, very recent report in November 2021 by the Market and Research focusing on basically India's emphasis on port and ship building. And they basically gave the framework or a study basically identify port and shipping industry in India, current scenario and the impact of COVID. They also focus on the overview of ports infrastructure in India, status track in 2030. They also try to talk about the overview of the ship repairs and building in India, start track 2030. Then the overlook of ship repairs and building, etc., till 2030. So this 2030 is very important. That is the end year of the achieving of the UN Sustainable Development Goal also. So my focus is that India and Russia has been a close friend for decades together. So there is a very, very substantive likelihood of meaningful cooperation, economic cooperation, leading to the strengthening of blue economy, whether it is through shipbuilding. And I have been listening the various speakers focusing on the different aspects of shipbuilding, technical aspects. So the idea is that shipbuilding basically is a very technical project where the engineering is required, where the medical sciences, where the, you see, digitalization technique, robotics, artificial intelligence, all those techniques or technologies are required in the blue economy also. And in IORA, we have identified 8 sectors under the blue economy, and shipbuilding is one of the, shipbuilding and ports is one of the sectors agreed by all the IORA countries under the blue economy, aquaculture and fisheries, you see, deep sea mining, ocean renewable energies, coastal tourism. So these are the some of the areas which we have identified under the IORA blue economy context. And now basically, as I mentioned in my earlier part of the presentation, that IORA has been committed to the blue economy and it is taking very bold steps. The meaningful projects are also coming. So my suggestion is, my hunch is that the cooperation in the blue economy should not be limited to a particular regional economic grouping. It should go all over the world. So that is why I cited the case of Arctic Council, I cited the case of BRICS, I cited the case of IORA. So in that context, summing up my presentation, I would say that the important things which emerges from my presentation, one is understanding the real nature of the blue economy and linking it with the green economy as well as with the circular economy. That is one. The another second point is that blue economy is not independent of accelerated technological change. It requires technical cooperation. Then the third thing is that blue economy is the extension of development activities or all economic activities leading to development, rather I should say sustainable development in the ocean space. So in that way, there is a link between the land economy as well as the ocean economy. The next point is that basically it should be integrated with the landlocked countries also. The another point basically is related with the financing of the blue economy. And then most important point is, which is also one of the very important key point of cooperation in IORA, technical trainings, training programs, joint projects training programs, creating the scientific networks, understanding or identifying the common areas of interest between the different regional economic groupings, and strengthening the blue economy and sustainable development through bilateral arrangements, as in case of India and Russia. So these are the things which are must to fight the post-COVID period and lead to the healthier human life as well healthier ocean life. You see, healthy oceans are must for healthy human life, and that together basically will make this planet peaceful and prosperous, and will be attaining the sustainable development of all the countries under the globe, as well as will be able to complete or achieve the UN Sustainable Development Goal by 2030. So with this, I stop my presentation. Thank you very much.
Thank you, Professor Atri, for your presentation, and you have explained how relevance of
Спасибо большое. Пожалуйста, Вадим.
and also you brought...
Вадим Гончаров у нас сопредседатель сессии вместе с профессором Раджу. Давайте объявляйте.
Да, я хочу сказать большое спасибо профессору Атри за очень интересные концепции вот голубой экономики, которую он высказал. Вот, и вот вы, значит, поняли вот эту систему движения к этому идеальному состоянию, когда все будет гармонично развиваться, не нанося вреда окружающей среде. А теперь я хочу представить профессора Кирилла Рождественского. Он вот выступит с сообщением. Кирилл является ведущим специалистом в нашей стране в области теории крыла и вот в различных ее применениях. Вот при его деятельном участии были созданы совершенно новый тип аппаратов морских. Это вот экранопланы. А сейчас Кирилл применяет свои методы теории крыла к созданию, вот, можем сказать, голубых подводных аппаратов, которые вот работают, движутся, не выделяя никаких вот, значит, парниковых газов. Пожалуйста,
спасибо,
Кирилл.
Спасибо. Коллеги, спасибо за возможность выступить. Спасибо профессору Атри за интересное сообщение по голубой экономике. В связи с тем, что он главные вещи сказал, я постараюсь быть очень кратким, потому что у нас есть дефицит времени. Вы прекрасно знаете, что одним из измерителей загрязнения морской среды является так называемый индекс энергетической эффективности, проектной энергетической эффективности. Он называется EEDI, и он введен Международной морской организацией и продвигается сообществом классификационных обществ. Речь идет о снижении выбросов СО2. Да? И кроме того, мы знаем, что в Париже в 2015 году была конференция, которая тоже установила некоторые пороги по загрязнению. Это необходимо для спасения человечества. В то же время, как мы все знаем, именно судоходство, которое перевозит большую часть грузов, очень сильно загрязняет морскую среду. Здесь мой доклад конкретно рассматривает моделирование судов с крыльями. Это энергосберегающие крылья, как один из способов уменьшения выброса СО2. Я не буду читать тексты, а сразу покажу картинки. Значит, на крыльях уже давно устанавливаются, на судах давно устанавливаются крылья для умерения или уменьшения качки. Это известные успокоители качки. Крылья, здесь вы видите примеры и из физических опытов, и CFD, вот крыло, да, и вот крылья, которые используют такие животные, как манты, морские животные. И Здесь есть интересный опыт. Вот справа внизу модель судна с двумя крыльями в носу и в корме движется против волнения. Это вот интересный механизм, который показывает, как можно использовать энергию волн. Ну, в России уже где-то в 80-х годах появились такие интересные проекты и реализации. Вот здесь вы видите сейнер, рыболовецкое судно российское, которое было оборудовано крылом в районе бульба, носовой оконечности. Это крыло прикреплялось к судну на угловой пружине, на муфте. И поэтому во время движения судна при наличии качки это крыло постоянно создавало дополнительную тягу, и при этом была отмечена экономия топлива в 10%. Сейчас в связи с голубой экономикой мы все вернулись и к таким способам снижения выброса. Вот ниже показана модель, которая испытывается нашими коллегами в Норвежском технологическом университете. Мы в Корабелке много занимались крыльями различными, и жесткими, и гибкими, и системами крыльев, которые позволяют эффективно реализовывать тяг, создавать тягу. И вот модель судна, справа внизу модель судна, на котором установлены в районе носовой и кормовой оконечности крылья. И мы в двух словах посмотрим, что это дает. Ну, тоже примеры устройств, использующие эти эффекты, это так называемые волновые глайдеры. Вот волновые глайдеры слева. Это волновой глайдер разработки нашего университета. Справа известные волновые глайдеры, которые созданы компанией Liquid Robotics и компании Kinetic, соответственно, Соединенные Штаты и Великобритания. Смысл здесь такой, что волны раскачивают корпус. Корпус соединен с крыльями, крыльевой модуль находится внизу, и крылья начинают перемещаться и создают тягу. Тем самым практически эти устройства могут двигаться чисто за счет волновой энергии океана. Сейчас. Ну, когда появляются формулы длинные, всем становится скучно, поэтому я очень быстро покажу. Это математическая модель. В этой математической модели мы пишем уравнение продольной качки судна. Продольная качка содержит килевую качку и вертикальную качку. К этому судну, математическая модель, да, прикреплены крылья. Вот на нижней половине слайда мы видим крылья, установленные в носовой и в кормовой оконечности. И мы умеем записывать уравнения качки под воздействием волн с учетом крыльев. Мы считаем эти уравнения. Таким образом, мы получаем движение судна с крыльями, а дальше входим в теорию машущего крыла. Крыло – это движитель. И вычисляем тягу или упор. Если крыло создает упор, это значит мощность энергетической установки будет использоваться меньше, и, соответственно, будет меньше выхлоп углекислого газа в атмосферу. Вот цель этой работы. Значит, это работает для любых удлиненных корпусов, а суда у нас все удлиненные. Для крыльев большого удлинения, примеры, которые здесь будут показаны быстро, это контейнеровоз типа С-175 с различными крыльями. Что дают крылья? Вот это просто апробация нашей модели, сравнение с другими методами без крыльев. А вот что дают крылья. Вот если вы посмотрите, красным это амплитудно-фазовые характеристики, амплитудно-частотные характеристики. Красная кривая – это судно без крыльев, а синие кривые – это судно с крыльями. Как мы видим, ну, в данном случае для регулярного волнения, да, как мы видим, резкое снижение происходит качки, снижение качки. Это важный эффект установки крыльев, но не зря они используются до сих пор как успокоители качки. Ну, а если речь идет о нерегулярном волнении, на самом деле это то, что происходит в действительности, то есть мы смотрим для данного бассейна спектр волнения нерегулярного, и мы можем тоже спектральные характеристики качки подсчитать. Вот посмотрите, что получается при нерегулярной качке, которая имеет место в действительности. Опять синие кривые – это без крыльев, а кривые другого цвета, в основном желтого и красного, это с крыльями. Резко уменьшаются амплитуды качки. Это важный момент. Значит, мы здесь таким образом установили, что качка уменьшается. Оказывается, как показывает наша математическая модель, уменьшается и дополнительное волновое сопротивление, что позволяет еще более эффективно использовать мощность, установленную мощность энергетической установки. А вот здесь показаны некоторые характеристики осредненные, включая индекс EEDI, который на самом деле показывает относительный объем выброса СО2. И мы математически для любого корпуса удлиненного и для любых комбинаций крыльев можем посмотреть, а насколько уменьшается выброс СО2 и насколько уменьшается индекс EEDI, контролируемый Международной морской организацией. Я должен сказать, что в теоретическом плане мы продвинулись далеко, в практическом плане в ковидный год интересные вещи сделали наши норвежские коллеги из университета в Трондхайме. Это Норвежский технологический университет. Вот посмотрите, значит, здесь показано судно Тейстинг. Вот слева в верхнем ряду первое. Это пассажирский паром, на котором установлено носовое крыло, только носовое крыло. Как только возникает волнение, оператор нажимает на кнопку, и как вы видите, вот справа внизу выдвигаются крылья. Лучше, когда они выдвигаются при наличии волнения. Если волнения нет, это просто дополнительное сопротивление. Так вот, значит, тоже опыт эксплуатации, примерно год это судно эксплуатируется, показывает, что имеет место экономия 10% топлива. Это значит автоматически, что имеет место уменьшение выброса углекислого газа. Посмотрите, как сделали наши коллеги. Они взяли судно из существующего флота и в носовую часть поставили устройство с выдвигаемыми крыльями. Вот здесь показано, как эта вся система работает. Видите? Смотрим дальше. Еще одна интересная вещь, которую наши коллеги из Трондхейма сделали. Они взяли катамаран, который движется на батареях. Сейчас технологии ион-литиевых батарей очень сильно развиты. И тоже получается, что потому что если есть волнение, экономится запас энергии батареи, и возникает возможность фактически движения за счет волн. То есть то, к чему мы стремимся, это и есть голубая экономика, это и есть использование непосредственной волновой энергии океана. Так, сейчас. Вот это все, что я хотел сказать. Я на этом могу закончить. Значит, это как один из способов. Мы поставили, во-первых, мы опубликовали, это можно найти в журнале Journal of Marine Science and Application. Это Springer Nature. Такой доклад также поставлен на World Maritime Technology Conference, которая должна быть весной 2022 года в Дании. Мы этим вопросом занимаемся. Это как один из способов сделать так, чтобы экономика моря была голубой, чтобы действительно мы не портили атмосферу и морскую среду. Спасибо.
Спасибо, Кирилл. Это было очень интересное сообщение. Это действительно новое направление, которое позволит существенно снизить нагрузку на атмосферу в смысле выброса парниковых газов. Спасибо большое. Очень интересное сообщение.
Спасибо.
И я думаю, наши индийские коллеги заинтересуются этой идеей в своей судостроительной промышленности.
Вот следующий доклад у нас идет.
Следующий он.
Да. Сейчас будет доклад нашего замечательного коллеги из университета Пондичерри. Это профессор Субраманиам Раджу. Будет такой доклад, да? Пожалуйста.
Yeah, thank you. Thank you. And my presentation is on maritimization of the world and developing blue economy. Am I audible?
Yes, sir, please go ahead.
Yes. So in my first presentation, in first part of my presentation, I look at how one can see the process of maritimization of the world. And the second part, I will see how important one can see the developing of blue economy.
For the moment, we don't see your presentation. Please.
No, I don't have. Mine is powerless PowerPoint. I don't have PowerPoint.
Yeah, sure.
Yeah. So now when you
share the screen, you have to share the screen.
Pardon?
Professor, sir, do you have the PowerPoint presentation?
No, I don't have.
Oh, okay. It's up to you to decide. Maybe you don't use it.
And so when I talk about the maritimization of the world, we look at how the strong linkage between human development and the seas. And we have seen ocean as a resource, ocean as a means of transportation. Ocean is seen as information and connecting people and states. And we know that the sea or ocean connects people, whereas land divides people. And we have 151 coastal states, whereby we all look at how the process of maritimization across the world. And also, as mentioned by the previous speaker, by Professor Atri, that even landlocked countries are also depending on sea, because most of their trade is also largely traversed through seas. So thereby, most of the countries, either the coastal state or landlocked state, is by and large heavily depending on sea. So in that sense, we talk about my proposition where how the process of maritimization of the world one can see or one can accept. And we know about how ocean has become instrumental to connect all parts of the world. And globalization stems from water. The trade goes, most of the trade, nearly 95% of trade goes through waters. Thereby, we look at how globalization starts from sea or ocean. 85% of the countries in the world have a coastline, and 75% of the world population live in the literal less than 200 nautical miles. And 80% of the capital of different cities or different countries or international trade centers are located on the coast. And we see that 36% of the world's ocean are encompassed within exclusive economic zone. Above all, as I mentioned to you, 95 or to 97% of the trade by volume is traversed by sea. And maritime trade has become a dominant factor in global affairs. Thereby, one can see how the process of the world, one can see how one cannot ignore the process in which we are now stuck. Thereby, we have to give importance to the ocean and ocean's governance. And now my second presentation, due to pass of time, my presentation is very short. I will make it, and I'll look at now the second part of my presentation is on relevance or how a coastal state will look for developing blue economy. And blue economy is a global trend, and it has become now one can see ocean has become an economic force in the 21st century, and coastal and ocean economies are often blurred, not quantified. And that is something where we are not giving importance, particularly Indian context. We look at that India is not giving more importance. Probably, I look at as a student of maritime studies that the audit of the revenue which comes from sea, perhaps not able to be done by the government. Therefore, the concentration of the focus regarding maritime could be, I think, neglected to larger extent. And when we are talking about the economy, it is a blue economy, the various sectors, as we know very well, it is not that new process in which we are now looking at blue economy, that it goes from coastal tourism to exploration of oil, gas, to deep shipping or ferry services or coastal protection or marine mining or offshore mining, etc., etc. But then how do we look at why this blue economy has become important? Why? Because ocean health comes into picture. When we are talking about ocean wealth, we need to look at that ocean should be healthy. There is a link between ocean health and ocean wealth. Thereby, we are bringing this notion of blue economy with the consciousness of having this sustainability in our process, in our exploration of resources. Further, as mentioned by Professor Atri, we need to look at about the maritime spatial planning, which is very, very essential. Either a country has the longest coast or a state is having a very vast EEZ, it doesn't matter if a state doesn't have this planning, maritime spatial planning. I think that is something very important. Or in other words, one can say blue clusters or maritime clusters. And this is something to look for minimizing the conflicts among the stakeholders and maximize the benefits that people receive from the ocean and help maintain healthy marine habitats. And this is something also we need to look at. It is not that maritime spatial planning, it is confined to the state, but also it needs to be expanded with the other countries, either at international level or at global level or regional level, because some of our activities go beyond 200 nautical miles, either in terms of fishing, either in terms of shipping or cable laying, etc., etc. And MSP is a process to develop a blueprint for area-based management that accounts for multiple management objectives in the marine environment. I think this is something where we need to look at, and the main objectives of the maritime spatial planning could be minimum space with maximum economic and social benefits. I think that is something where we need to look at how big a state is, doesn't matter, because we need to look at the limited space, optimum benefits. And we have to look at the survey or through satellites where the fishing could be possible, where we can make more fishing available, where the trade is important, where the trade facility to be given, where the shipping is important, where the port is to be developed, how the conducting the commerce is very important when we are talking about a country which is seen as a coastal state. And also we need to look at about the connecting between the sectors. When we are talking about shipbuilding, not necessarily we should look exclusively on shipbuilding, because there are associated sectors that need to be also given importance by any state. So in that sense, we need to look at, because trade also matters when we are talking about shipbuilding. We also need to look at how much trade a country is depending in terms of exporting or importing. And also we need to look at the resources which are available. That also makes a country to think more about importance of or to what extent in a country can devote its funds for shipbuilding. I think that is something which we need to look at, and the sectors which are related to maritime activities are necessarily to be connected each other, because they are interlinked and they are depending on each other. Otherwise, that will not really help us. And that is happening in Indian context. For due apology, I look at India, as somebody mentioned in the previous presentation, that India is contribution is only 1%. If you look at it, is before British came to power or before Mughal, I think India was seen as a seafarer, or India is having a strong in terms of having the capacity to build very good, strong ships, and that capacity of 800 to 1,000 capacity. That is now totally missing. Then it is now going to other countries which are now taken over the kind of contribution for the shipbuilding. If that is the case, then I think we need to bring this MSP. We have to bring this blue cluster. Thereby, that will really help us to look at how to prioritize. And also blue economy, when we are talking about, it is also sometimes also, I may be permitted to say this, that every 100 kilometers, the priorities will be changed. This, whatever the area in which we are discussing, after 100 kilometers, the priorities may be changed. So there is something where we need to give more importance to how to have approach in terms of developing blue economy. And we have the challenges. It is not that I have to give a rosy picture about that all the advantages being a coastal state or looking at developing blue economy, we will get more advantages. But then on the other side, we have challenges, because when you look at this ocean governance, equally very important, because 40% of the oceans are affected by pollution, either by debris or plastic, and depletion of fisheries and expanding coverage of jellyfish. When you are looking at fishing is one of the very, very traditional sectors in any coastal state, and jellyfish is the one which can really spoil the whole activity in terms of fishing. I think there we need to look at, give more importance. And this is something where we look at about how these oceans become a demand for over 3 billion people depend on marine and coastal biodiversity for livelihood. And when we look at the marine and coastal resources are contributing to $3 trillion a year. That means 50% of global GDP. I think that is something where we need to look at. And also this blue economy or maritime spatial planning would also really help us in case when there are any conflict between two human users, either for instance, fishing or the offshore oil gas development, or conflict between user and the environment. So that is something where we need to look at how these MSP could really help the countries to look at how to reduce the conflicts and how to maximize or optimize output. I think I think this is one area where India and Russia could really probably, we look for MSP, we look for the clusters, we look for the shipbuilding, we look for how to audit the revenue which come from sea. Thereby they can give more importance for blue clusters or marine clusters. I think this is something where we need to look at. We have to bring this business opportunity. We have to bring the collaboration. We have to bring the private participation. We have to share the knowledge. We have to look for competitiveness. Otherwise, it's very difficult. On one hand, we are talking about sustainability. On the other hand, we are talking about profit. And that is something where there is a challenge for us, that we need to invariably bring this MSP or blue clusters or blue economy invariably into in our policy. Otherwise, it will be very, very difficult to look at. And that is something where we need to get experience from different countries, right from Malaysia, Seychelles, and the other countries. And finally, I look at that how this governance at sea is very, very important, because in blue economy, security also can become as one of the aspects. And that is something very important, because for instance, if you look at piracy cost the world economy about $18 billion a year, and pirates can have jurisdiction or can go to extent of 700 nautical miles, whereas the state has only 200 nautical miles. Sometimes pirate is more powerful than a coastal state, because coastal state was given 200 nautical miles by United Nations Conventional Law of Sea. So in that sense, when I would like to conclude in my presentation that ocean should be seen as instrument of cooperation, and we should look at the convergence of interest between the countries, particularly India and Russia, and we have to look at how these oceans are lost frontiers and needs to be careful in exploring resources. And we need to look at the technology to be shared, and we have to invest on research and development. And 21st century has been called as the century of the seas. So oceans represent a new economic frontier for growth, development, and investment. And finally, I end up by saying that economic growth and ocean health are complementary to each other. And to err is human, to err continuously is a policy making. Thank you. Thank you, Professor Kirill.
Большое спасибо, профессор Раджу. Передаю слово профессору Гончарову. Там еще у нас... вы сами. Так делайте сразу такое.
Yes.
У него доклад по экологии морской среды.
Вот это, да, сейчас я секунду включу. Ага. Мне даже щелкать, да?
Щелкать вот.
Ага. Мне очень приятно сделать презентацию перед индийскими коллегами. Я это делаю впервые, и вот тоже хотел обратить внимание на проблемы вот голубой экономики. Вот одним из аспектов реализации этой политики голубой экономики является предотвращение загрязнения морской среды. И вот наиболее характерное, одно из наиболее характерных загрязнений морской среды – это загрязнение вот углеводородами. И одна из причин этого загрязнения – это вот аварийные ситуации при добыче и транспортировке нефти. И вот в настоящее время эта проблема очень актуальна для нашей страны, для России, в наших арктических акваториях. Это связано с тем, что в настоящее время разрабатывается большое количество месторождений нефти и природного газа, и развивается транспорт вот, нефти и жидкого газа по Северному морскому пути. И вот при добыче и транспорте углеводородов могут произойти аварийные ситуации. В условиях ледовых подвижек и других ситуаций, связанных с ледовыми условиями, суда могут сталкиваться, могут быть повреждены льдами, сжатием льдов, так что либо, значит, вот у нас будет повреждена обшивка, либо это приведет просто к затоплению судна. И в многих случаях вот нефть будет разлита на поверхность льда. При добыче нефти может быть фонтанирование из скважины, может быть разрыв шланга, по которому подается нефть, может быть просто разлив нефти из подводного трубопровода и просто вот разлив из-за небрежности нефти на поверхность льда. Нас, конечно, больше всего интересует проблема разлива вот с танкера. Здесь нарисована ситуация, которые показывают, что в результате сжатия льдов льдина пробила корпус судна и началось вытекание нефти в окружающую среду. И вот нефть может попасть на поверхность льда, может выливаться под поверхность льда или вот в канал за танкером, который образуется при его движении. Условия растекания нефти по поверхности льда отличаются от растекания нефти по водной поверхности. Если на поверхности воды нефтяная пленка может растекаться до тех пор, пока ее толщина не уменьшится до 1 микрона, то в ледовых условиях процесс кардинально отличается. Дело в том, что вот в среде воздух, лед и нефть, вот контактный угол на границе нефтяной пленки составляет десятки градусов, и поэтому толщина пленки, которая образуется при растекании нефти, составляет 3-4 миллиметра, а подо льдом этот контактный угол может быть близок к 180 градусам, и толщина пленки, до которой растекается разлитая нефть, всего доходит до 6-8 миллиметров. Вот исходя из этой концепции взаимодействия нефти со льдом в водной и воздушной среде были созданы модели растекания нефти, загрязнения льда. Вот верхняя модель – это для растекания по поверхности льда, это время растекания и диаметр, который достигнет пленка на поверхности льда. Нижние формулы – это для растекания, время для растекания нефти подо льдом и размер пленки подо льдом. Самая нижняя формула относится к распространению нефти в битом, мелко битом льду, мелких льдинах. Другой вариант – это растекание нефти в следе, в ледовом канале за танкером. Ледовый канал заполнен обломками льда, поэтому нефть растекается и испытывает сопротивление течению со стороны воды, как и обычно в море без ледового покрова, по боковым поверхностям льдин в следе, в канале и на бортах канала. Вот модель, которая учитывает всех эти эффекты, она создана нами и позволяет оценить скорость растекания нефти по ледовому каналу в зависимости от времени и концентрации льда в канале или сплоченности. Вот тут есть иллюстрация внизу этих результатов расчета. Ну и когда мы создали вот эти модели растекания нефти при повреждении танкера, то мы можем сказать, что реальные условия в Арктике очень далеки от тех идеализированных условий, для которых создавались модели. Это связано с тем, что ледовый покров имеет самые разные формы. Это связано с тем, что под действием погодных условий лед дрейфует, под действием ветра, волн, существуют морозы, туманы, обледенения. Ну и кроме того, у нас в Арктике есть полярная ночь, когда нет дневного света и вообще ничего невозможно увидеть. Вот разнообразие ледовых условий. Это начальные формулы льда. Это ледовые иглы. Дальше идет ледовое сало, идет значит, шуга, идет это название вот формы льда. Вот шуга, значит, вот нилос, темный нилос, светлый нилос. Вот это, значит, лед, похожий на обломки стекла. Дальше идет блинчатые льды. Дальше льды смерзаются, эти блинчатые льдины, и образуется молодой лед. Дальше процесс намерзания продолжается, и образуется лед, однолетний лед, толщина которого меняется от 30 сантиметров до 1,20 сантиметров. Но в Арктике есть и многолетние льды, старые многолетние льды, толщина которых достигает 3 метров. А летом происходит таяние льдов. Вот это melting ice, это отдельные льдины, которые пронизаны вот вертикальными каналами. Значит, лед может быть связанным с берегом, это значит припай называется. И лед может дрейфовать в виде больших или маленьких льдин по поверхности моря. На льду могут возникать торосы и гряды торосов. Ну и вот столько форм льда, и мы должны задать себе вопрос, возможно ли это, необходимо ли это, имеет ли в этом какой-то смысл развить математические модели для каждой формы вот ледового покрова в Арктике. И никто не знает правильного ответа на этот вопрос. Тем не менее, мы знаем, что нужно продолжать исследования в этой области, потому что климат Арктики теплеет, и вот льды могут таять, и ледовый покров может значительно меняться вот в ближайшее время. Те же самые вопросы возникают для вот проблемы ликвидации разлива нефти, то есть очистки моря от разлитой нефти. И что здесь делать? Нужно ли нам развивать создать средства для уборки разлитой нефти, которые могут быть эффективны для всех форм ледового покрова? Или же мы должны создавать для каждого ледового покрова свои средства, эффективные для сбора различной нефти? Это тоже очень вопрос сложный. И поскольку решением проблемы очистки морей и океанов от нефти занимается очень давно, то, естественно, попробовать применить развитые для вот, свободных от льда морей вот эти методы и устройства и подходы для вот наших арктических морей. А арктические условия очень значительно отличаются от значит, обычных морей, вот, которые окружают Индийский океан, который окружает Индию. Вот Арктика большую часть года покрыта сплошным ледовым покровом. Видите, вот здесь, значит, в центре Арктики это сплошные льды, сплошной ледовый покров и припай около берегов. А практически чистой воды большую часть года вот не существует. Это температуры воздуха в Арктике по трассе Северного морского пути. Самое теплое место – это средняя температура в январе минус 6 градусов. Это в Баренцевом незамерзающем море вблизи Мурманска. А вот в области моря Лаптевых или море Восточно-Сибирское, тут средние месячные температуры минус 30 градусов. Но еще больше нас впечатляют экстремальные низкие температуры. Вы видите, что вот в море, Карском море температуры экстремальные до минус 50 градусов, а значит, в море Лаптевых минус 70 градусов, а в Восточно-Сибирском море даже минус 75 градусов. Я понимаю, что у вас в Индии даже себе невозможно представить таких температур, но в этих суровых вот условиях, как вы видите на приведенных фотографиях, когда все обмерзает, все, значит, останавливается, все равно должны суда работать, вывозить нефть и, значит, сжиженный газ, несмотря на все трудности. Но в этих условиях это все, конечно, очень сложно. Что такое вот полярная ночь? Полярная ночь, когда солнце не встает выше горизонта и дневной свет практически отсутствует, вот в нашей Арктике длится гораздо больше месяца и двух, и достигает даже 3 месяцев. И вот вы здесь видите, вот сюда в этих условиях, тут только вот это полярное сияние, а это ледокол идет, и он должен вокруг себя все пространство освещать с помощью прожекторов, потому что вот дневного света нет. И поэтому, когда мы все это посмотрели, у нас опять возникает вопрос, можно ли это вот решить проблему, создать методы для вот уборки разлитой нефти, которые будут эффективны в столь суровых зимних условиях, когда у нас мороз ниже минус 50 градусов, а, значит, отсутствие естественного света длится больше 3 месяцев. Ну и можно ли будет какие-то уже существующие средства применять вообще, вот разрабатываемыми средствами, применять вот в таких экстремальных условиях? Для того, чтобы эффективно бороться с разливами нефти, нам необходимо решение следующих задач. Это предсказание вот, растекания нефти, чтобы планировать операцию. Значит, надо иметь средства и оборудование для сбора нефти. Нам нужно, значит, руководство для операторов, как им это делать. Нам нужно, чтобы операторы имели опыт таких работ. И кроме того, у нас должна быть постоянная готовность оборудования персонала для выполнения вот этих условий. Что же в настоящее время делается для решения проблем? Делается достаточно много. Значит, это тут, значит, показано, какие проблемы уже решены для открытой, свободной ото льда воды. Как же это реализуется в Арктике? Ну, всем известны боновые заграждения. Они могут быть применены только в тех случаях, когда у нас отсутствует сплошной ледовый покров, и они могут ограничить растекание нефти между плавающими льдинами. Вот для сплошного ледового покроя можно только вот рекомендовать такие заграждения, которые предотвратят растекание нефти. Есть вот специальные алиофильные, то есть не взаимодействие с нефтью материалы, которые позволяют создать скиммеры, которые работают среди битого льда. И они могут быть защищены от того, чтобы вот в эти, значит, средства сбора нефти попадали и застревали, блокировали их вот льдины. Значит, у нас есть суда, которые могут использовать эти вот средства. Эти суда созданы и разработаны в нашей соседней стране, Финляндии. Это вот судно Турва, судно Летто и Лохи. Значит, они оборудованы и могут работать в этих условиях. Созданы средства, которые могут отмывать, снимать, значит, нефтяное загрязнение с отдельных льдин. Ну, предлагается использовать сжигание нефти, вот, собранной вот, с помощью буксируемых бонов или просто, значит, на поверхности льда. Существует инструкция по проведению всех этих операций, которая создана вот, Арктическим советом. Проводятся учения, полномасштабные учения по вот сбору нефти вот, в ледовых условиях. Первое такое учение было проведено в Финляндии, в Кеме в 2015 году. Второе учение проведено в 2018 году, тоже в Финляндии, в Оулу. Ну, потом пришел коронавирус, который мы все знаем, и сейчас вот такие вещи осуществить, в общем, затруднительно. Что у нас имеется? Это была Финляндия, это был Ботнический и Финский залив. Что у нас имеется в настоящее время вот в Арктике? В Арктике на трассе Северного морского пути существует 4 порта, которым есть средства для ликвидации вот разливов нефти, специальные спасательные суда, значит, вертолеты, самолеты, которые могут вот обнаруживать разлитую нефть. Это, значит, у нас Диксон, порт Тикси, порт Певек и порт Провидение уже в Беринговом море. У нас есть 2 ледокола, которые имеют на борту оборудование для ликвидации разливов нефти. Это дизельный ледокол «Адмирал Макаров» и вот ядерный ледокол с ядерной энергетической установки «Вайгач». Вот такая ситуация. Значит, у нас специальные средства для борьбы с разливами нефти имеются на платформе «Приразломная», которой, значит, добывается нефть из, значит, вот месторождения на дне. И такие же средства на терминале, который стоит в Печорском море и который вот грузит танкеры нефтью, которая добивается на береговом участке. Ну и теперь, когда я вам все это рассказал, что у нас есть, мы задаемся, значит, вопросом, достаточно ли они эффективны, если что-то случится и придется их использовать. Ну, этот вопрос нам пока неизвестен, поскольку и не было ни крупномасштабных учений, и не было еще ни одного реального разлива. И мы только должны вот мечтать о том, чтобы не пришло такое время, когда придется все это, значит, оборудование использовать. Но, конечно, и надо быть готовым к тому, чтобы это все понадобится делать. Благодарю вас за внимание.
Уважаемые коллеги, спасибо большое за сессию. Спасибо, Вадим Константинович, за интересный доклад. Если есть вопросы, пожалуйста, можем выслушать.
Ну, я думаю, у нас времени мало, поэтому вопросы можно вот адресовать по электронной почте на университет, и я с удовольствием отвечу на эти вопросы. И, конечно, было бы очень интересно для меня вот сотрудничать с учеными Индии в части вот всех проблем, связанных с разливами нефти, не только в ледовых условиях, но и в условиях открытого моря. Ну и вот как вот куратор этой секции, я хочу сказать, что у нас очень интересная получилась вот работа нашей секции, потому что наши индийские коллеги хорошо нам обстоятельно рассказали о концепции, о философии голубой экономики, которая развивается на базе океанов и морей, которые окружают наши страны. А с нашей стороны, с российской стороны, мы доложили конкретные практические решения, которые могут реализовать эту концепцию, философию голубой экономики. Спасибо.
Спасибо. Профессор Раджу, если у вас есть комментарии, которые вы могли бы дать, мы бы рады были вас выслушать. Professor Raju, are you here?
Все ушли уже.
Professor Raju?
Yes, sir.
Do you have comment?
Yeah. You can proceed, sir.
Долго.
You can proceed.
Хорошо, тогда, уважаемые друзья, уважаемые коллеги, позвольте, мы перейдем к сессии номер 7, одной из заключительных сессий. Это университетское сотрудничество. Сопредседателями сессии у нас является профессор Раджу, ранее упомянутый, а также профессор Владимир Николаевич Тряскин. Он является выпускником Санкт-Петербургского морского технического университета, профессором, заведующей кафедры конструкции и технической эксплуатации судов. Пожалуйста, Владимир Николаевич.
Добрый день, коллеги. Мы сейчас дадим слово нашим ученикам, нашим будущим ученым. Послушаем, чем же занимаются они у нас в стенах нашего университета, чем занимаются у вас. Значит, я бы хотел сказать несколько слов о том, какие направления работы мы вот сейчас хотим представить. Первое направление работ связано с разработкой систем автоматизированного проектирования судовых конструкций. Эта тематика развивается в университете значительное время. Приблизительно с 70-х годов прошлого века мы занимаемся вопросами автоматизированного проектирования судовых конструкций. И в настоящее время я думаю, что мы достигли значительных успехов, о которых вам расскажем, в плане разработки таких специализированных автоматизированных систем. Кроме этого, один доклад будет посвящен проблемам проектирования конструкции судов ледового плавания и ледоколов, которыми также в университете занимаются с 70-х годов прошлого века. Наша кафедра конструкции является автором одних из первых правил российского регистра по проектированию конструкции ледоколов и судов ледового плавания. И в настоящее время мы также продолжаем совершенствовать требования этих правил в связи с тем, что Арктический флот в настоящее время очень сильно изменился. Он, совсем практически по своей форме корпуса, по мощности, не соответствует тем судам, которые проектировались и строились в 70-х годах. И, соответственно, требования к конструкциям корпуса судов должны изменяться. Вот это, небольшая информация о том, что мы будем сегодня слушать с нашей стороны. И первый доклад, который мы сейчас вам представим, называется «Разработка программного обеспечения для проектирования корпусных конструкций». Авторы этого доклада – преподаватель кафедры конструкции судов Плотников Кирилл. Ну, правда, по объективным причинам он сейчас присутствовать не может, поэтому этот доклад представит его наставник, который непосредственно с Кириллом работает. Нет, под руку, сейчас Сергей. Угу. Вот он, Сергей.
Добрый день, уважаемые коллеги. Можно я свою презентацию включу для демонстрации?
Да, конечно.
Да, спасибо. Вы видите, да, презентацию мою?
Мы пока видим только тебя.
Загружается.
Да. Так, видно, да? Видно презентацию мою?
Видно.
Спасибо большое. Тогда я начинаю, уважаемые коллеги и организаторы конференции. Для меня большая честь и удовольствие выступить перед вами сегодня. Я представляю совместный доклад от группы исследователей кафедр конструкции и проектирования судов нашего университета. Заранее, да, прошу прощения, что делаю доклад я, а не мой коллега молодой Кирилл Плотников. Он сейчас по ряду причин не может делать этот доклад. У него еще выступление в другом месте, к сожалению. Кафедра конструкции и технической эксплуатации судов успешно работает с 1932 года. И в настоящее время руководит ею уважаемый сегодняшний ведущий нашего семинара профессор Тряскин. И наша кафедра ежегодно выпускает до 70 студентов. Это бакалавры, инженеры и магистры. И на кафедре, как вы видите из этого слайда, наблюдается эффективный баланс между опытными профессорами и молодыми преподавателями.
Сережа, мы пока слайд не видим. Следующий, наверное. Мы видим только первый слайд, название.
Интересно. Я вот уже третий даже включил. Сейчас. Не переключаются слайды, вы имеете?
Нет, да, только первый слайд.
Давайте я заново включу демонстрацию экрана. Мало ли что. Сейчас, одну секунду. В данный момент что-то появилось новое у вас?
Пока нет. Вот, да. Это какой слайд? Не знаю, первый или второй. Вот как вчера началось, после обеда. Сейчас, Сереж, проблемы со связью сейчас решат.
Просьба мне сообщить, когда вы будете меня видеть и слышать.
Так, Сережа, сейчас, похоже, второй слайд видим.
Да, вот хорошо, и я вас вроде бы тоже вижу. Перейдем к третьему слайду. Надеюсь, он виден вам. Основные направления научной деятельности. Отлично. И основными научными направлениями кафедры являются вот приведенные на этом слайде. Первое – это арктическое направление, и в том числе оно выражено в участии в разработке и совершенствовании правил Российского морского регистра судоходства. Вторая часть – это то, о чем я буду сегодня рассказывать. Это автоматизированное проектирование судовых конструкций на основе правил Российского регистра. Третья часть, третье научное направление – это автоматизация оценки технического состояния судов. Четвертое направление – это плавучие доки, автоматизированное проектирование их конструкций. Здесь показан такой исторический экскурс, перечень работ нашего коллектива за последние 30-35 лет. И первый опыт автоматизации проектных и конструкторских работ сотрудники кафедры получили еще в 80-х годах прошлого века. И с тех пор постоянно развиваются методики и программное обеспечение автоматизированного проектирования судов и плавучих доков. И сегодня, вот если смотреть последнюю запись внизу, мы разрабатываем комплексные решения для создания 3D-моделей и проектирования судовых конструкций, которые удовлетворяют всем требованиям нормативных документов. И эти решения максимально приспособлены под задачи, которые решаются в условиях конструкторского бюро. Здесь показаны логотипы нашего программного обеспечения. Я некоторые слайды буду в целях экономии времени очень быстро проходить, поэтому, если будут вопросы, можете потом писать на почту. У нас будет указана почта в конце. Задачи, которые решает наше программное обеспечение. Я теперь говорю в основном про программное обеспечение, связанное с конструкцией судов. Состоят из создания 3D-моделей судовой поверхности, внутренних конструкций судовых помещений, а также ввод и обработка данных по всем листам и балкам всех перекрытий судна, расчет общих местных нагрузок, устойчивости, усталости в виде проверки конструкции на соответствие требованиям правил регистра. И вторая цель – это поддержка принятия решений для подбора оптимальных толщин и сечения элементов. Здесь коротко покажу. Это моделирование судовой поверхности на разных стадиях проектирования судовых конструкций. Это то же самое, что связано с моделированием поверхности плавучего дока. Здесь показан пример создания модели поверхностей тех, которые будут служить основой в дальнейшем для создания конструктивных моделей. Это поверхности внутренних конструкций. То же самое мы делаем с отсеками и помещениями судна. Мы задаем их параметры и геометрические модели, которые показаны на этих картинках. Также в нашем программном обеспечении существует универсальный, общий для всех возможных вариантов судов каталог судовых конструкций. Из этого каталога инженер при работе выбирает только те конструкции, которые присутствуют на его проектируемом судне. На этом слайде вы можете видеть моделирование поперечного сечения судна, ввод балок и листов для этого поперечного сечения. Это такой рабочий момент, когда проектант выбирает параметры листа будущей конструкции. Также мы работаем и с балками. Здесь показано окно работы с балками, то есть ввода элементов балок судовых конструкций и выбор одного из вариантов закрепления концов балки для последующего расчета усталостной долговечности. Это fatigue calculations. Мы работаем не только с сечениями, но и с трехмерными перекрытиями, с трехмерными моделями судовых конструкций, то есть не только с плоскими. И здесь показаны все балки, листы, также нанесены районы ледовых усилений судна, границы перекрытия, и мы создаем полноценную модель судовой конструкции практически по всей длине судна. Вот здесь показано трехмерное представление бортового перекрытия судна, и решается очень важная задача разбиения конструкции на элементарные листовые панели. То же самое работа с поперечными конструкциями плавучего дока. Здесь показан пример алгоритма автоматической процедуры для поиска границ элементарных листовых панелей. И дело в том, что общие правила МАКа, они требуют расчета прочности не целиком для листа, а для большого количества очень маленьких листовых панелей, которые находятся между балками набора перекрытия. И для каждой этой маленькой панели дальше проводятся все расчеты общей местной прочности, устойчивости и другие. И чтобы найти такую панель, приходится применить достаточно сложный поисковый алгоритм. И пример успешно работающего такого алгоритма приведен на этом слайде. Также здесь показан пример подготовки данных для расчета общей продольной прочности. Это расчет распределения массы судна по длине судна и расчет изгибающих моментов и перерезывающих сил для нескольких случаев загрузки судна. Также в нашем программном обеспечении есть расчеты ледовых усилений судна. И вот пример подготовки данных для этих расчетов, то есть в верхнем таком окошке вы видите, это расчеты параметров формы корпуса судна, углы наклона ватерлиний и шпангоутов. И внизу это полностью автоматизированное, это делается без участия сейчас человека, выделение на корпусе судна районов ледовых усилений. Это пример расчета характеристик поперечного сечения судна, ну, эквивалентный брус, как мы все знаем это название. Также в программном обеспечении проводится расчет предельной прочности. Это Ultimate Strength Check. Причем он делается не только для судна в начальном состоянии, но и для судна, получившего повреждение, днищевое или бортовое. И вот здесь пример приведен расчета предельной прочности для днищевого повреждения. Также по алгоритму, приведенному в общих правилах МАКа, проводится распределение перерезывающих сил по элементам конструкции, расчет секториальных моментов, которые нужны для расчета кручения, нагрузок от кручения контейнеровозов. И вот этот слайд, он показывает один из важных моментов, который сделан в нашей системе, это интеграция в нашу систему расчетов методом конечных элементов. И у нас реализована автоматическая передача данных в программное обеспечение, которое позволяет делать расчет методом конечных элементов. И вот некоторые результаты расчетов вот такого моделирования здесь приведены. Вот, причем хочу отметить отдельно, что сама программа вот этого конечно-элементного моделирования, результаты действия, которые вы видите здесь, это тоже разработано в нашем университете. Также можно отдельно отметить решение поисковых задач. Дело в том, что программное обеспечение такого рода, которое мы знаем во всем мире, оно в основном решает задачу проверки, то есть чек судовых конструкций на соответствие нормативным требованиям. Но в нашем программном обеспечении реализованы задачи поиска и подбора таких характеристик конструктивных элементов, которые позволяют в дальнейшем не только удовлетворить требованиям правил, но и минимизировать массу конструкций. То есть это создание оптимальной конструкции. И для этого применяется ряд математических поисковых методов. Вот. Здесь показан набор ограничений и целевая функция для вот этих поисковых алгоритмов. Ну, в качестве целевой функции мы обычно используем минимизацию массы конструкции. Что мы делаем сегодня? Вот чем конкретно мы занимаемся на сегодняшний день? Мы развиваем, конечно, наше программное обеспечение и его алгоритмические основы. Проводим подготовку сейчас к очередной сертификации наших программных модулей. Одна из важных задач, которую ставит перед нами проектное бюро, это передача наших моделей и результатов расчета в системы автоматизированного проектирования судов. Например, это система АВЕВА. И в данный момент эта задача почти решена. Мы в процессе уже завершения этой работы. Также мы проводим разработки и тоже достаточно успешно передачи трехмерных моделей в систему ANSYS. Вот, и создаем универсальный XML-документ, который принимается многими автоматизированными системами. Вот пример отсека танкера, который создан в системе ANSYS через автоматизированный командный язык APDL. И вот такая конструкция создается по результатам нашего моделирования в нашей программе. Это пример использования XML документа для передачи в системы конечно-элементного анализа, FEM-Analysis. Ну, на этом я хотел бы завершить мою короткую презентацию и полагаю, что те исследования, о которых я говорил, вполне соответствуют тематике молодежного семинара, так как вот в разработке того, что я перечислил, принимают участие всего 4 опытных профессора и разработчика программного обеспечения, и более 6 молодых ученых, аспирантов и студентов. И мы постоянно увеличиваем количество вовлеченных в данную работу молодых людей и надеемся, что вот наше сотрудничество с индийскими университетами тоже добавит нам молодых исследователей в будущем. Спасибо за внимание от меня и от Кирилла Плотникова, автора этой презентации.
Спасибо большое, Сергей, за ваш доклад, за ваш вклад в автоматизированное проектирование.
Развитие.
Да, то, что вы вносите. Я бы хотел попросить индийских коллег поставить доклад
Yes, may I request Ajmal Farhan?
Excuse me, Mr. Raju?
Yes, sir.
Mr. Raju, мы один вопрос. Я бы хотел попросить поставить доклад нашей аспирантки, следующий, как развитие предыдущего доклада. Вот, если позволите.
А ваш доклад после?
Да. А доклад профессора Аджмала Фархана следующий.
Не понял.
Can you hear us?
Okay.
Okay. Okay.
Окей, да? Да. Уважаемые коллеги, сейчас мы представим доклад, связанный с проблемой проектирования конструкции ледовых усилений на арктических судах. И этот доклад сделает аспирант кафедры конструкции судов Диана Тимофеева.
Здравствуйте. Меня зовут Исаева Диана, я являюсь аспирантом СПбГМТУ и хотела бы в сегодняшнем выступлении по теме проектирования ледовых подкреплений на арктических судах развить такую тему, как проблема проектирования ледовых усилений для судов с вертикальным бортом. Да. Вот. Хотела бы сказать, что расчет параметров ледовой нагрузки на район носового заострения с вертикальным бортом вплоть до 2019 года не регламентировался правилами регистра. То есть требовалось привлечение прямых методов расчета по методике, согласованными с регистром. Это связано с тем, что существующее решение задачи об ударе вертикального борта о кромку льда пока не удавалось представить в виде рекомендаций, пригодных для использования требований правил РМРС. Но стоит отметить, что существует большое количество судов, которые имеют бульвообразные обводы и вертикальные борта в носовом заострении. Поэтому разработка правил представляла большой интерес для судостроения. И уже в 2019 году правила РМРС для ледовых категорий от АС-1 до АРК-7 включительно допускаются бульбовые обводы носовой конечности, для которых характерно наличие участка с вертикальным бортом. И давайте рассмотрим этапы разработки требований для расчета нагрузок ледовых усилений для судов с вертикальными бортами и бульбообразными обводами. Первый – это анализ решения задач об ударе корпуса судна вертикальным бортом о кромку ледового поля. Второе – это создание требований для расчета нагрузок на вертикальный борт, который включает в себя анализ формы корпуса судов и создание сетки неарктических и арктических категорий судов. Выбор метода построения расчетных зависимостей, принято решение применить метод планирования экспериментов и разработка расчетных зависимостей для определения параметров ледовой нагрузки. И заключительным этапом является верификация расчетных зависимостей. Стоит сказать, что требования правил РМРС для определения ледовых нагрузок на корпус судна основаны на гидродинамической модели удара твердого тела о лед. Модель Курдюмова и Хессена, разработанная в 1975 году. Эта модель была построена на экспериментально обоснованном факте вытеснения из зоны контакта тонкого промежуточного слоя мелкодисперсного раздробленного льда. Также при ударе вертикальным бортом о кромку ледяного поля соотношение сторон зоны контакта зависит от глубины внедрения борта судна в лед. И зона контакта является вытянутой в вертикальном направлении при малой глубине внедрения, и вытеснение промежуточного слоя происходит преимущественно в поперечном направлении. Квадратная зона является... вытеснение происходит промежуточного слоя одинаково в поперечном и вертикальном направлениях, а вытянутое в горизонтальном направлении – это при большей глубине внедрения вытеснение промежуточного слоя преимущественно в вертикальном направлении. И как вы можете видеть, как раз-таки представлено на рисунке, как изменяется зона контакта льда с бортом.
Малое внедрение.
Да, малое внедрение, квадратное, и это среднее как бы внедрение промежуточное, и вытянутое уже прямоугольным. Так. Также хочу заметить, что в своем выступлении основное внимание уделю судам неарктических категорий, поэтому разберем создание, разработки неарктической сетки судов. Для этого выполнена обработка статистической информации, заимствованной из регистровой книги судов. И перед вами график зависимости длины судна от водоизмещения. Далее представлена ширина судна от водоизмещения, высота борта, осадка, все от водоизмещения и дедвейт. И на основе этого была создана сетка неарктических судов, которая имеет изменение водоизмещения от 1000 тонн до 200 тысяч тонн. И теперь стоит сказать о алгоритме планирования эксперимента. Первое, что необходимо сделать, это отбор существенных факторов и оценка реальных границ области их определения, где альфа – это углы наклона ватерлинии к диаметральной плоскости в расчетном сечении, а XL – относительное отстояние расчетного сечения от носового перпендикуляра. Второе – это формирование матрицы планирования эксперимента, и согласно представленной формуле число экспериментов при двух варьируемых параметрах будет равно 9. Третье – это выполнение численных машинных экспериментов над программной моделью, формирование массива значений функций отклика. Производилось с помощью программного комплекса iStar и iSloads+, цени Крылова. Четвертое – это выбор модели определения коэффициентов регрессии. Была выбрана квадратичная модель полином второго порядка. Уравнение представлено на слайде. B и T – коэффициенты регрессии, и X и T – независимые варьируемые переменные. И последним этапом это оценка адекватности модели путем оценки относительного отклонения расчетных значений от предсказанных уравнением регрессии. Расчет нагрузок выполняется в соответствии с матрицей планирования эксперимента для каждого водоизмещения из разработанной сетки судов. Выполняется для 2 и 10 режима базовых опасных режимов движения судна. Эти кривые сокращенно борт, представлены на рисунке. В качестве среднего принимается 6-й режим базового опасного движения. Далее определяется отклонение нагрузок от среднего значения для всех расчетных случаев и, соответственно, выполняется построение регрессионных зависимостей. Таким образом, получена следующая система расчетных зависимостей. Перед вами представлено уравнение для определения давления, высоты и длины зоны контакта для неарктических и арктических судов. Далее мы проверяем, насколько насколько с правильные формулы получились, поэтому нам нужно их проверить на прототипе. В качестве прототипа выбрано нефтеналивное судно типа Фромакс проекта С-919, у которого вертикальные борта, продолжительность вертикальных бортов от носового перпендикуляра вплоть до цилиндрической вставки. И главные размерения представлены на слайде. Этот танкер имеет класс 1Б финско-шведской администрации, что соответствует по правилам Российского морского регистра АС-3, классу АС-3. Так. И самое главное, что нас интересовало в нашей работе, это форма корпуса, поэтому большое внимание уделено именно форме корпуса выбранного прототипа. Видео нету. Видео не знаю. Так, перед вами теоретический чертеж этого танкера. Далее вы можете видеть распределение углов наклона ватерлинии и углов наклона шпангоутов к диаметральной плоскости. Красные – это углы наклона шпангоутов.
Нулевые,
да? Да, как видите, они равны нулю. И синим – это углы наклона ватерлинии к диаметральной плоскости. Вот. Ну, и получили мы следующие результаты для давления, для интенсивности ледовой нагрузки. Представим также эпюры. Это интенсивность ледовой нагрузки, высота зоны контакта и длина зоны контакта. Ну, соответственно, можно сделать следующие выводы, что максимальное значение погонной нагрузки соответствует сечению с вертикальным бортом, бета равное нулю. Максимальное значение погонной нагрузки соответствует 10-му режиму на кривой базовых опасных режимов движения для всех классов и водоизмещений. И высота распределения, соответствующая максимуму погонной нагрузки, соответствует толщине льда для 10-го режима кривых базовых опасных режимов движения. Ну, также мы произвели расчет определения размеров конструкции ледового пояса. И в заключение хочу сказать, что эти требования с 2019 года включены в действующие правила регистра и успешно применяются. Спасибо за внимание.
Спасибо, Диана. Уважаемые коллеги, я еще буквально несколько слов скажу в смысле этой работы. Дело в том, что до 2019 года определение ледовых нагрузок на конструкции судов с вертикальными бортами не было возможным. Но судовладельцы просили исправить эту проблему. И вот в связи с этим появились разработки этих требований. Такие суда, это суда, как правило, имеющие бульбовые обводы в носовой конечности. Если до 2019 года бульбовые обводы разрешались для слабых ледовых категорий, то по просьбе, опять же, судовладельцев, они были разрешены до категории АРК-7, то есть до арктических категорий. Поэтому эта работа была очень важна для того, чтобы можно было бы расширить возможности требований правил. Ну, вот все, что я хотел бы добавить к докладу Дианы. Ну и следующий доклад, это будет доклад Аджмал Фархан.
Он неделю еще.
Professor Kirill, may I please intervene?
Sure. Sorry,
Professor Kirill, will you please respond?
Вмешаться.
Professor Kirill, time management absolutely in trouble. the chief guest, what we are invited, we had given him the time of 4:30. Now we have to manage some time schedules. We have got senior vice admirals who will be concluding the session. May I request you for the time management and then advise us how do we manage? I'm sorry, but MRO sessions you manage the time, other sessions you manage the time. We have to take control.
Ну, я предлагаю, когда адмирал придет, дать ему слово. I suggest when the admiral comes, let us give him the floor immediately.
No, admiral asking time, you please tell me the time, because his is a concluding speech. So he wants to know what time shall be given.
Хорошо, хорошо, хорошо.
So may I intervene, sir?
Так, давай посмотрим, сколько у нас.
May I intervene here, sir?
We have two presentations. Maybe we could reduce the time to 10 minutes each, if possible.
Professor Kirill.
Sure, Professor.
No, it is only one presentation. The second presentation won't be there. So can we allow one presentation from Indian side, and we will
Одна
conclude.
презентация, да?
And we will request the speaker Ajmal to
Какую?
10 minutes.
Which one? This would be
10 minutes.
Gajula or Ajmal?
It is by Mr. Ajmal, who is on the screen ready now.
Ajmal. Okay, let's go forward.
Yes.
Sure.
That is
Sorry
going to be the
about
first
all this.
presentation in this session.
Thank you, sir. Thank you.
Professor Raju, shall I request Admiral to join at 5:30?
Before that, sir, I think 10 minutes, Mr. Ajmal will take 10 minutes only. Now time is 5:05. So 5:20, I
5:15.
think. 5:15
Okay.
or 5:20. Yes.
Thank you.
Thank you, sir. Go ahead, Mr. Ajmal, please go ahead.
Sure, sir. Thank you, sir. Thank you. Good afternoon, ladies and gentlemen. I assure you that I'll keep on with the time limit. And it is indeed an honor to present my topic in this opportunity. First of all, my topic is on on maritime domain awareness, or MDA, a determinant of maritime security. First of all, let me explain what is MDA, or maritime domain awareness. According to International Maritime Organization, MDA refers to the effective understanding of any activity associated with the maritime environment that could impact upon the security, safety, economy, or environment. In short, a maritime domain awareness means the knowledge of sea and whatever related to it. But MDA is often regarded as the tool for surveillance and monitoring ships. But this is a very narrow approach towards maritime domain awareness. Maritime domain awareness not only includes tracking threats and monitoring ships, it also includes knowledge about the amount of pollution and its effects on marine environment, knowledge about rising sea level and effects on coastal community, and also it is also necessary to disseminate proper warning of environmental hazards, to detect fishing grounds, to track endangered species and preserve them, and to explore marine resources and identify gas and oil deposits. MDA is also relevant for keeping track of resource exploitation and to maintain sustainability. And search and rescue operations are also not possible without ample maritime domain awareness. So MDA is the concept that includes military, security, blue economy, and environmental aspects. So now let me explain how MDA is important for shipbuilding. In order to build various technologies for both military and civilian ships, we need to be aware of underwater environment, such as bathymetry and temperature of the sea, etc. Not all kinds of ships can sail in, for example, in ice. It needs various kind of technologies. So for this, and also this temperature, the characteristics of sea is different in characteristics, not same everywhere. It is different. So to understand this kind of environment, we need a well-equipped research fleet. While we are focusing on shipbuilding, we also have to focus on building technologically advanced research fleet too. So next, we also have to make sure the security and safety of ships and people from the threats like piracy and environmental threats. We need advanced warning system and proper management in order to ensure security and safety of the ship and people. So we also need a well-equipped search and rescue rapid action force for the rescue operations. Here, I would like to share an instance which happened in Kerala, which is also called as Godson country, where a boat wrecked in 11 nautical far from coast of the Kerala, and 4 fishermen stranded at sea. The police and rescue workers tried to rescue them, but they were not able to rescue them. But later, a boy, 19-year-old graduate boy, suggested to help them with his own personal drone camera, which he uses for photo shoot. And he used this. He suggested for helping them, and he went with this police and rescue worker to rescue those 4 fishermen. And they were able to do it. I admire the work, the courage and kindness the boy did. But the point here is the sad condition of our authorities. They were not able to get this kind of technology or equipment for rescuing them. So my suggestion here is that first of all, we have to change our approach. We have to reconsider our approach towards MDA. Indian maritime doctrine explains MDA as an all-encompassing term that involves being cognizant of the position and intentions of all actors, whether on or hostile or neutral in the constantly evolving maritime environment in the areas of interest, which is this definition of MDA is just confined to surveillance and tracking threats, which is a very narrow approach towards MDA. And secondly, when we take the case of piracy mitigation in the Indian Ocean, external powers like China and Europe are acting as MDA provider in the region. There is a lack of regional MDA agent. India should make use of this opportunity to collaborate in developing its MDA capabilities and technologies along with shipbuilding. And recently in August, Russian President Vladimir Putin had committed his willingness to cooperate in combating maritime crime in the UN Security Council debate on enhancing maritime security, case for international cooperation chaired by India. And finally, I would suggest that along with shipbuilding, we should also focus on developing research facilities and also enhance maritime domain awareness capabilities. And I would like to conclude by saying that maritime domain awareness is the key to become a maritime power. Thank you.
Это заканчиваем все, да? Да, можно начать. Thank you very much for your presentation. And what is usually said in this case, this is the last but not the least. So thank you very much, and this is very symbolic that a young person is finalizing the conference where there's been the whole range of ages and range of experiences. So may I ask our Indian colleagues whether we can give the floor now to the Admiral, or at least inform him that he is very welcome to finalize.
Good afternoon, ladies and gentlemen. It's my great honor to welcome Vice Admiral Dilip Deshpande to the session. He's on the screen. Sir, thank you so very much for accepting our invitation for the concluding address. Professor Kirill and Professor Raju, you will be speaking. Before Professor Raju takes the floor, I will take this opportunity to reintroduce Admiral Deshpande to our audience. Admiral Deshpande has had an illustrious career in the marine domain as well as the aviation domain. And he is a specialist on the various Russian systems which are being used both in aerospace and the marine domain. He has had a distinguished contribution to the Navy in establishing the operational and the maintenance facilities, both in the marine environment as well as the aviation environment. And I have been honored to work with Admiral. I am really honored to say that he has been my mentor, my guide, and my philosopher who has brought me today where I stand. Admiral has been a pioneer for the Indian Navy into the fields of marine and aviation, and the things what he have done for the Indian Navy are even today acknowledged as an example. We are really fortunate to have Admiral in our concluding session. Admiral sir, once again, very warm welcome. Professor Raju, floor is yours. You are on mute, Professor Raju.
Extremely sorry. Good evening to everyone. And in this session, we are going to conclude our today webinar on shipbuilding. This is something very important where we are having a guest who has been involved and contributed in shipbuilding. And we are very, very grateful to have Admiral Deshpande, who is being with us today and going to give Admiral's address, and which is going to really help us to look for further interaction between the two countries, particularly between the two universities, SRMTs and then Poндичерри University. So we look forward to hearing you, sir. Thank you, and may I now request Admiral Deshpande to speak to us. Over to you, sir.
Thank you, Professor Raju. Thank you, Srikant, for the very kind words. It was always a pleasure working with you right through our lives at various stages. And I'm glad to see that you are keeping very busy in spite of the fact that it is late. I'll take a little time, though I did not attend all the sessions, but what I saw when I was co-chairing the first session, and thereafter in bits and pieces what I've seen, I felt firstly very happy. Technologically, I felt a little challenged in the sense that I'm used to doing the same thing in the presence of everybody in a hall, and therefore this kind of presence, which everybody is in his own area and we are just online together, was a little daunting, but I think it is being managed very well by both the sides, the Indian side as well as the Russian side. There were a few technical glitches, but they can be, they were handled well, and I think they were, as we go along on this path of webinars and what we call the remote presence and so on, my generation will find it a little difficult, but the next generation, they're used to it, in the sense that today even the primary school children are now attending classes online. So it's okay. I think the next generation will take to these technologies very easily. What we need to hand down to them, ladies and gentlemen, is all our gathered experience, not only what we gathered, but what was handed over to us by our forefathers, and what we learned and what we experienced and what we developed in terms of going to sea. Basically, shipbuilding and so on activities, basically it involves going to sea. And that is something that you cannot do remote. You cannot be online and be at sea. You have to go to sea. And for that, you require ships, you require platforms. And for this webinar was precisely for that reason as to why and how we need to develop even more than what we have developed today, because it's a continuously evolving process. For one reason or the other, there is a requirement for improvements. There is a requirement for improvements on the material side. There's a requirement to improve our design capabilities. There is a requirement to do things a little more efficiently, so that we need to cut down the shipbuilding times by using better materials, by using better designs. So all these, I'm happy to see that all these things, it's not only that I feel that this is required, but the entire community which has gathered on this online for this webinar have all put their minds to that problem. That is how to improve things, how to make things better. And then we hand it over to the next generation that, look, we have brought you up to here and now you go further than this. And that's the object of such webinars. And here I would like to highlight that India and Russia have been very, very close without making a song and dance about it. Of course, our defense cooperation has always been there, but even apart from defense cooperation, which started much later, Russia helped to put in place steel plants of huge capacities in India. And this was done so well that today we are almost okay with steels. And I was very happy to have been a part of the system when we started clearing the Indian steels for our aircraft carrier. It's not easy to get something like that, but we managed it. Like this, there are a lot of technological inputs from Russia to us. There are a lot of, now that we have developed our capabilities, we have built some ships, we have built many ships, in fact, both merchant ships and warships of different varieties. We should be able to exchange these ideas in this manner, either by webinar or by visiting each other, go to each other's shipyards. I have been to many Russian shipyards. I've been to Sevmash, I've been to Zvezdochka, I've been to Admiralty, I've been to northern shipyards, I've been to Kaliningrad, and so on. And every place, even within Russia, I found that there were differences. For example, if I saw something in Sevmash, I was able to ask the same question, hey, in Kaliningrad, why are you not following the technology which is there in Sevmash? Now, if that can happen in Russia, you can imagine how much we will benefit if Russia and India exchange their technologies, their technical knowledge, their experiences, how much more we both can progress. Suffice to say that these are my thoughts on this question of holding such webinars and holding such interactions, because I have had a lot of interactions with the Russian side, both in aviation as well as in the shipbuilding and the submarine building side. And I've always come out richer with experience. And the same process should be the other way around, that whatever we can offer, we should offer to the Russian side. It's not very easy to conduct such international webinars, but I must say that the sessions are very, very well conducted. The new technologies in shipbuilding have been identified, and I'm sure that those who go away from this webinar will now put on their thinking caps and say, okay, what did I learn from this webinar? What can I do in my shipyard or in my organization to now make things a little better? Both sides can do something to improve. I always said that whoever comes to a job, if he can make an improvement of not 100%, I used to always say in your appointment, just do a 20% increase. 10% also is acceptable, but 20% would be atlichna, as we say. So all the people who have attended the webinars, I exhort them to not just attend a webinar and go home. Now think about what you heard, what you saw. There is a problem of languages, though thanks to my association with the Russian side, I was able to even read and understand most of the slides, even if they were in Russian. But that's okay. I mean, everybody doesn't understand, but over a period of time, the language problem can be got over. Industry 4.0, this needs to be addressed very carefully. Advanced manufacturing techniques, the requirement to do advanced outfitting, getting to higher and higher levels of outfitting in the workshop, making the blocks and the super blocks and so on, so that when you go to the slipway or to the dry dock, it should be like Lego pieces. You just fit them together, weld them together, connect them together, and launch. From the time you come to the block and start assembling the ship to delivery, it should be the fastest possible time. And cutting down the build periods is very important because it affects two things. It affects the cost and it affects the availability of a ship. So both these are important. And yesterday, even the general manager from L&T said very clearly that whereas in the military ships, delays are acceptable, but let me just make a small correction. It is when it becomes a fait accompli, when you cannot do any other way, then we accept the delays, but we don't like it. And it actually affects us. I know that when you're looking for a ship and the ship doesn't come, you have to keep an old ship going. And I had to keep an old ship going. And as an engineer, I can tell you, it takes half your life away when you're trying to continue with an old ship when her age is too much. So timeliness of the deliveries should be ensured, and that can be done by very meticulous planning. There are various tools now available. A lot of software is available with all these things, and the GSL gentleman yesterday, he brought it out, how they're using the computerization, the digitization to do things faster. Apart from that, I would say that the efficiencies have to come in. You cannot accept a situation where you give a delivery period of 2 to 3 years and then thereafter you take another 4 or 5 years to deliver an item. That's not acceptable anymore. And in this competitive world, what will happen is that if you're not on time, somebody else will be on time and he will take away the business from you. Now, we're all good mariners, we're all good scientific people, we're all good engineers, but eventually shipbuilding, at the end of the day, shipbuilding is still a business. And in business, if you're not on the ball, then somebody else will take the ball away from you. Whilst doing all this, we cannot forget the impact it has on the environment. And the sea, although we don't realize it, but there is a lot of attention now being paid to treating the sea as a place where you cannot accept anything, any dirt being put, any muck being put. We cannot hand over to the next generation a sea or an ocean which is more dirty than what we got. In fact, if possible, we should make it much cleaner than what we inherited. Our generation went through a phase where we were all growing and technologies were there, not there, and there was understanding, not understanding, and so on. That is okay. But now there is even the younger generation. Now they are asking us a question: what kind of world are you going to leave for us to live in? And I would like to tell them that I'm going to give you a world which is cleaner. I'm going to give you seas which are cleaner. I'm going to make sure that there is not any pollution. I'm not going to make sure that we will not have Arctic ice melting and submerging some of the low-lying islands and so on. We should give them a world which is better than what we inherited. I was also happy to see that there are some students who took part in this. It's a very heartening sight to see a student coming up with ideas. A young generation, when they start thinking, then we can retire. Finally, I would say that everyone understands land, everyone understands fields, everyone understands factories. There is not so much awareness of what is the sea, what is the ocean, what is the life at sea. And that maritime domain awareness needs to be created in more and more people. You and I, we understand sea. But I would like to see many more people understand the implications of going out to sea, sailing on the oceans, diving under water. If that understanding comes, as a humanity, we will make progress. It's the same whether you go into the sea, under the sea, or you go into space. When you explore new areas, then as a complete human race, we will move forward. With these few words, I would like to thank the organizers and everybody who has participated in this. Excellent participation. Congratulations and wish you all Godspeed in your endeavors. Thank you very much.
Thank you so very much for your address, sir. Very motivating. And the message is very clear that we need to learn our lessons from what has been discussed in this webinar. And not only learn, but implement the lessons what we have learned. Thank you so much, sir. Very, very powerful message, sir. We appreciate it. Thank you.
Thank you.
Professor Raju.
Okay. Professor Raju, who speaks now?
Professor Kirel, I think you should sum up the proceedings and give your thoughts. And finally, Professor Raju will give the vote of thanks.
Спасибо. Я хочу сразу поблагодарить адмирала Дешпанде, который на самом деле открыл наш вебинар и закрыл его. Причем то, что он рассказал, оно раскрывает души и таланты. Мы все работаем на море, на морскую технику, но прежде всего мы работаем на человека, на людей, на нас с вами, на Содружество Индии и России. На мой взгляд, наш вебинар, который длился примерно 6 часов каждый день, 2 дня, прошел достаточно успешно. Тематика была весьма актуальной. Участники были очень квалифицированными и очень знаменитыми. Участвовали различные предприятия, организации. Это и университеты, и проектное бюро, и заводы, и корпорации. С нашей стороны, скажем, это участвовала и Объединенная судостроительная корпорация, и корпорация морского судостроения. Я думаю, что действительно этот вебинар очень своевременный, поскольку, насколько я понимаю, скоро встречаются наши руководители. И я думаю, что мы нашим вебинаром приветствуем эту встречу для дальнейшего развития сотрудничества. Я хочу поблагодарить наших индийских коллег за очень активное участие в организации. Это прежде всего коммодора Дэшмука, с которым мы стали большими друзьями, и его команду. Хочу поблагодарить и собственно, компанию, корпорацию САН ЭЛКОМ. Хочу поблагодарить посольство и Российской Федерации, и Индии за внимание к этому вебинару. Конечно, большую роль сыграли и такие организации, как Минпромторг, и многие наши организации здесь нам помогали. Хочу отметить роль компании НЕВА, вот Анастасия Сиет, которая помогла нам и помогает нам и с publicity, и с технической поддержкой. Вот здесь Вадим сидит, который, значит, все трудные моменты старался ликвидировать, и, на мой взгляд, он это все ликвидировал. Поэтому окончательно хочу всех поблагодарить с замечательным вкладом в ваш вебинар. Думаю, что мы создали хорошую практику, которую должны повторить в будущем. Большое вам спасибо. Всем я желаю здоровья, счастья и успехов в труде на благо судостроения, морской техники, исследования океанов, экологии и так далее. Спасибо всем большое. Что-то хочешь добавить? Нет? Да, нет, сказали, да?